All right, good morning, everyone. Hi, welcome to EnergyTech Up 2024, our national event. We're very excited that everyone's here for this competition. We're excited about all the work that you've done to date, excited about the presentations that you have for today. So I'm Joe Simon. Many of you have seen me on Zooms, excited to see you all in person. I'm with the National Renewable Energy Lab, helping to operate this program for the Office of Technology Transitions at the National Renewable Energy Lab, or at the Department of Energy. I'm at the National Renewable Energy Lab. So Jackie, if we could advance, that would be great. So as you all know, and there may be some people from the conference as well, the EnergyTech University Prize is tasking all of you as student teams to develop and present a business plan leveraging national laboratory developed or other emerging energy technology. So this could be technology developed by faculty, developed by the students themselves, developed by others at their institution, or found from a national lab. So a wide range of technology, but the point for today is really about the business plans and how that fits within the context of the research that the students have done. So in this program, the competition winners are chosen on the strength of the plan, not the strength of their resumes or CVs. So they can be awesome people, and we hope that they are, but we also want to be able to have people competing where this is new to them, but they've put in the work, they've really understood the technology in the background as well. So with that, I'll turn things over briefly to our host from the Office of Technology Transitions, Mr. Edward Rios, a commercialization executive helping to advance technologies out of the national labs into industry, helping to advance industry overall. Welcome, Edward.
Good morning. Everyone looks so great. This is probably the most dressed up you'll be ever. So I want to welcome all of you. This is an amazing competition that has continued to grow throughout the years. This is our third year of competition, and we continue to grow. We continue to get lots and lots of feedback from industry, and most of all, it's become very well known at the department. We are working with 9 program offices that are contributing funds to this program, and we continue to grow. And we've had the most applications this year and the most students. It's amazing. So thank you all for putting in the time and effort. We continue to promote this program. You're going to see lots of articles throughout the week. And so I want all of you to take a deep breath. I want you to relax. And I want you to have fun, because this is going to be an amazing, amazing experience. Now I have to go to my script. For those of you who aren't familiar with OTP and our mission, we are the central hub for technology transfer activities across the department. So what does that mean? DOE is very well known for its research and development. And with all other research and development institutions, it's very, very difficult to take that technology and get it into the market. Some of you are probably experienced that already. And the department is no different. So our mission is to develop programs and resources to get those technologies into the market. And one of those tools is the Energy Technology Program. This allows us to foster strong internal and external partnerships that guide innovations from the lab toward the marketplace. And programs like the Energy Technology University Prize are what bridge the gap between the incredible work developed in our national labs and its availability to the public. It's not often that you find a program like this that challenges students to research a highly technical topic and become subject matter experts, while also creating a strong commercialization plan to bring that technology to market. This competition is so unique because it gives you a full spectrum of what it takes to bring a new technology to the national and even global industry. But above all, no matter what your career path is, this competition has given you all experience in business development, technology, finance, project management, and beyond. I'm so impressed with everything that you've accomplished so far. And so today is going to be the cherry on the cake. I can't wait to hear it all. So I wish you all the best of luck. And thank you for being leaders in our energy future. Back to you, Joe.
Thank you so much, Edward. So again, many of you have seen this before. Many of you have heard me say it many times, but I'm going to say it just one more time, then you'll be done, because then you'll present. You won't have to hear me say it anymore. But as Edward mentioned, we're so excited that we started with 225 teams representing 39 states. So the teams presented their ideas at the end of February after registering on February 1st, so just a few weeks later. And then about the top 15% of teams are here today. So we have 28 teams represented at this pitch event, and looking forward to choosing 3 national winners, 3rd, 2nd, and 1st place, as well as up to 13 different bonus prize winners supported from different program offices at the Department of Energy. Excited. Oh, I have a clicker. Wait a second. You guys all have clickers too. I can do it myself. This is exciting. So we do want to thank all of our regional conveners that made it possible for 225 teams to present live. So as our staff, we would not have been able to do this without their engagement. And so for all of them who helped to host these regional events so that you could compete and present to judges that understood where you were coming from, whether it was the Northeast, whether it was Hawaii, whether it was in Florida or otherwise, these regional conveners really put in a lot of work to build up that network and to support all of the teams along the way. So while they're not here today, I do want to recognize their contribution to making it possible so that you don't just have to submit all of your entries into a void and then we say, great, these are the 10 teams we picked. So I hope that you enjoyed that process of pitching as well. So for today, we do have a number of prizes available. First place will be walking home with $50,000, second in $20,000, third in $10,000. And then as mentioned, we have a bonus prize for a team that leveraged a national lab technology. So I think we have 10 or so teams that found a technology from a national lab and integrated that into their business plan. And so we'll be choosing one of those for the technology bonus prize finalists for the national lab IP activities, as well as several undergraduate only teams. So again, I think it was about 8 or 10 teams that are undergraduate only teams as well. And then we also have technology bonus prizes ranging from water power to nuclear to carbon dioxide capture and similar. And so we're excited about all of those activities. So for today, our students get up to 6 minutes to pitch and up to 8 minutes in total, inclusive of Q&A. So if you present slightly less than 6 minutes, you get a little bit more time for Q&A. So use up the full 6 minutes. It's going to be very rushed with our judges. Speaking of judges, excited that we have some really amazing judges today. So thank you all for being here. Maybe have a moment. I'll let you guys briefly introduce yourselves, but very briefly. Edward already did himself. So Carrie.
Sure. Hi, everybody. I'm Carrie Rupp. I'm a venture capitalist here in Austin. We invest in women-led companies that are improving either human or environmental health.
Hi, everyone. My name is Kathleen Bayreuther, and I work with early stage deep tech companies that are doing decarbonization. Good to meet you.
Hi, everyone. My name is Mike Marr, long time in renewable energy finance, and that's where I met Ed over here back in the programs.
Awesome. Thank you very much. So our agenda today is pretty full. We heard last year that teams really value being here at the national event. And so we found ways to bring both our bonus prize finalists and our regional finalists here, but that doesn't mean that we have 28 of you here. So there's a lot to get through. And so we're going to do our best to stay on schedule. It is 8:10 and a half, so I need to finish up, but just about there so we can stay on schedule. The expectation is that you have 6 minutes to pitch, 2 minutes for Q&A. Then we have a 2-minute turn where the judges can make some notes and we can bring the next team up. So that's the 10 minutes per team that you see right here. And then we will have a break as well. So without further ado, I will walk through this activity. So we will have a morning break, go through these teams, then we will have lunch. And I do encourage you to take lunch. We do encourage you to attend the Energy Thought Summit opening session. They have a great keynote speaker. It'll be on the 3rd floor. You're welcome to be there for that opening session. And then we'll return for our final 8 teams. So with that, I'm excited to turn things over to, we're not on a break, unfortunately. But first up is GarboCarbo from Harvard University and the University of Illinois at Urbana-Champaign. Welcome.
I just spilled water on my suit, so if you see that, I'm sorry. But,
Minus 3 points.
okay, so hey everybody, I'm Pavan. I'm a junior at Harvard, and I'm the CEO of GarboCarbo. where our mission is to clean up the construction and paper industries by offsetting emissions and by decarbonizing the production of calcium carbonate and sulfuric acid. So right now, the construction industry emits about 23% of global annual emissions, the paper industry about 2%. But to make matters worse, the paper industry relies on raw materials like calcium carbonate and sulfuric acid, whose production results in millions of tons of CO2 emissions on top of that 2%. So at GarboCarbo, we kill two birds with one stone. First, by capturing atmospheric CO2, and then using that captured CO2 to offset emissions in the construction industry. And second, actually taking the atmospheric CO2 and converting it into calcium carbonate and sulfuric acid using renewable energy to sell at a discount for paper manufacturers. So over the last couple of months, we spent a lot of time de-risking the business model. I just want to touch on really one important thing. We've already secured letters of intent from paper manufacturers saying that they would buy our calcium carbonate and our sulfuric acid should we meet their chemical and pricing specification needs. These letters of intent accumulate up to $60 million in total annual revenue in the future. Our closest collaborator in this realm is WestRock, a public paper manufacturer. So we also want to emphasize that GarboCarbo has a tremendous opportunity to scale. These numbers say a lot, but I really want to just say that even when we're capturing over 1 million tons of CO2 annually, we'd only be eating up a small percentage of these markets, which means that as we actually get to scale, we'd have the capacity of being able to capture and utilize 1% of CO2 emissions, global CO2 emissions, that is. But to be clear, we're not the first company to capture CO2 or make calcium carbonate and sulfuric acid. There's really two types of technologies that already do this. Let's talk about the incumbent technologies first, the traditional methods. They're relatively cheap, but the main bottleneck for them is actually transportation costs. Taking the calcium carbonate and sulfuric acid and then actually moving it to the customers is really the main bottleneck for them. We completely eliminate this. As a direct air capture company, we're actually putting our facilities near or on site for our customers, getting rid of the transportation costs. Now, in terms of the newer technologies that rely on renewable energy, we've made significant energy enhancements, cutting energy costs threefold compared to our closest competitors. So for newer technologies, we cut costs by saving on energy, and for older companies, we actually offset their transportation costs. And so we're the cost leader in the field. Regardless of how much our competitors reduce their prices, we can reduce them even further. Now, just a quick overview of the technology. We take CO2 into a precipitator and output calcium carbonate with the help of our novel bipolar membrane electrodialysis, or BMED process for short. It takes in gypsum rock as an input. We'll talk about the CO2 implications of that a little bit later, but the important thing to know is that we also output sulfuric acid as a result of this process. Looking at our costs and our revenue, we see that we generate around $1,500 in revenue for every $200 spent. This is on a per ton of CO2 process basis. And we're hoping to deploy our first large-scale facility in Evadale, Texas, getting our renewable energy from the Heart of Texas wind farm and getting our gypsum from a local gypsum mine that's around 30 miles away from our actual deployment location. Once we have the capital to actually build out these facilities, and once we have the transportation infrastructure set in place to get the gypsum to our facilities, the actual operations is pretty simple. The energy that we put into the system is all that's needed to actually make the calcium carbonate and sulfuric acid. However, it's important to note that there is some maintenance involved. So once every 3 years, we actually need to replace all of the bipolar membranes in the bipolar membrane electrodialysis stack. That being said, we're raising around $1.9 million right now to scale up our small-scale pilot to a large-scale pilot that's actually going to be revenue generating. And we hope to do this by February 2025, so in bullet point 5. We hope to generate revenue selling our calcium carbonate and sulfuric acid generated from this large-scale pilot to WestRock. And from there, our process of scaling up actually just lies completely in line with what WestRock wants. We'd be increasing to a modular unit size of around 100,000 tons of CO2 captured per year. This is what WestRock wants. And from there, we continue scaling and basically modularizing that unit and selling those units of 100,000 ton capturing facilities to other customers as well. We really want to emphasize that GarboCarbo is sustainable on 2 different fronts, economically and environmentally. So first, the economics. Simply put, we don't even need the offsets. We can sell just calcium carbonate and sulfuric acid and we'll be profitable by 2031. Second, environmentally, we'd be capturing 1 million tons of CO2 by 2031, but we're actually removing about 840,000 tons. So 160,000 tons will actually be re-emitted as a result of mining, the pre-processing, and transporting gypsum to our facilities. With that said, though, we'd be displacing over 100 megawatts worth of dirty fossil fuel energy. with our technology. And the third point is often overlooked. By doing this displacement, we're actually cleaning up the air in areas around these dirty chemical manufacturers, which tend to be inhabited by marginalized communities. So by implementing our technology, we're also improving the air quality in these areas. So our technology also has tremendous health benefits. With that, I just want to say thank you. Happy to go first, I guess, and I'll take any questions.
Great job.
Thanks.
One question. I noticed that you said Westrock will begin purchasing
This is correct.
from the pilot scale.
That's correct.
They're actually going to purchase.
That's right.
Do they need to do any testing of the product before they actually agree to take it?
Yeah, so we need to meet their chemical specification needs. So for sulfuric acid, we need to meet their concentration requirements, and for calcium carbonate, we need to meet their particle size, which we've already done.
Okay.
We have to just send it to them. So
Yeah, related to that, can you say more about the TRL and MRL of your technology?
yeah, so the TRL, we're currently going from 3 to 4. And then for the MRL, we're actually almost complete with our market analysis, and we've also implemented all of the infrastructure needed to actually sell our products. So that's where we're at.
So to actually build the pilot, are the different component parts off the shelf, or does this have to be custom engineered as well?
So the actual membranes we're actually buying from a supplier, but everything else we're building ourselves.
So you can talk about what was proven then at a little more detail in the small scale pilot that you've done today. Are you doing both sides of the equation?
So it's just utilization for the pilot. So even at the large scale pilot, we'd just be utilizing CO2, buying CO2 and utilizing it. We've proven energy efficient numbers are exactly what we need in order to be profitable, even at the small scale pilot scale. We've proven the chemical specification outputs that our customers need. And we've also proven that we can synthesize the amount of calcium carbonate and sulfuric acid that's required.
We have time for one more question, like 30 seconds left.
The only question I had was, have you already raised any capital to date, and if so, how much?
Not venture, all non-dilutive, around 30, 40K in grants and student competitions and university money.
Great, thank you.
Yeah. Appreciate it.
Nice
All right.
job.
Thanks.
Great job.
How we do this.
Thank you so much. So while the judges are making some notes, I'll give you all, it's not actually a break, but I will give you a heads up that to get through some of these activities, I do have some terrible dad jokes. And that was just a joke about the paper industry, but it was terrible. Yeah, yeah, it's a terrible joke. Don't worry. I won't fold that easily. Not fold that easily.
Oh.
It is pretty thin humor.
Oh.
They're all paper jokes, all the way down. But how do you know what paper deserves a promotion? It's on a roll. All right. I'll look for the judges to make eye contact with me, and I roll after these terrible jokes. And our next team will be Manan Ahuja and Anshpat from team ChargeBay. Looks like they're still writing for a second, so we'll give that a moment. Who do we think traveled the farthest to get here? Is Hawaii here? Yes. I think you might have been our farthest. Anyone come farther than Hawaii to be here?
We got France in the back, come on.
France? All right, well, I guess you win then. Sorry, Hawaii. I don't know, which one
No, I
is
think
more
Hawaii is
mileage? I don't know, we'll have to see. All right, judges, we ready for our next team, just about? All right, so next is team ChargeBay for Manan Ahuja and Anshpat. Go.
Yeah,
All right.
got it. Yeah, thanks.
Not my notes. And we'll call it good.
About 5 years from now, almost 40% of us are going to have electric vehicles. However, the number of chargers are not reasonably rising enough, as they haven't for the past 5 years as well. According to S&P Global, 28.3 million EVs are going to exist in the future, and only 2 million chargers are going to be available for them. The exponential growth in the presence of EVs and mere linear growth in the presence of chargers is just going to create limitations for EV users and waste their time even more. Wouldn't it just be convenient if you could pre-book a charger at a location of your choice without even going there? Good morning, everyone. My name is Mellon.
And I'm Anshpan.
And we are ChargeBay, and this is exactly what we do. Well, a few months ago, I was in San Francisco renting a car, and I was surprised that they switched me to an EV. At first, I was really excited, but later, due to my tight schedule, I got battery anxiety. I had places to go to, but nowhere convenient to charge. All convenient spots were not available, and all available spots were not accessible to me. After this episode, I conducted some research to find that 70% of Americans want to switch to an EV, but don't due to battery anxiety. We conducted 500 interviews on the field to find that 65% of EV users feel accessibility, availability, and time to commute are the biggest barriers to make that EV adoption change. Now, you would be surprised to know that an average EV user in America at least wastes 100 hours annually just to charge their car. See, the way that electric grid works right now and in the future, level 2 chargers are going to be the vast majority of chargers available. A large proportion of these chargers are going to be privately owned. So our solution is our platform, our network, ChargeBay, that capitalizes on these privately owned EV chargers at residential or commercial locations that provide convenience to the users. Now, imagine this. You want to have your favorite gelato at Sausalito Bay. You know, it's a Saturday night, parking is going to be scarce, and your EV is at 10%. Now, before you even go, you can book a charger with Jane, who is a ChargeBay host, park and charge in Jane's driveway, and you enjoy your favorite Hawaiian sea salt flavor. How about that? Convenient, right?
For the user, being able to book in advance, being aware of the price beforehand, and having a guaranteed parking spot and a working charger are the biggest benefits. Businesses are reluctant to expand to EV charging despite current incentives. By reducing the footprint of a public charger to that of a private one, we incentivize business to adopt ChargeBay as hosts, increasing our customer base.
Our business model for the beta app is pretty simple. It's a simple pay-per-charge basis that provides high convenience to users and high output to monetary output to hosts. Later on, when the network is going to be reliable, we're going to have a subscription model rolled out that will provide businesses to acquire new customers through our network. By our conservative estimates, and I mean conservative, our total addressable market just for charging alone in 2024 is estimated to be around $2.56 billion. Now, that being said, we want to create a whole ecosystem around EVs to partner with rentals, hotels, services, you name it, and reach an evaluation that is currently evaluated at almost $40 billion, taking an average ticket size of almost $19 and conservative number of charges, almost 25 charges annually for 10 years. We get a customer lifetime value of almost $5,000 just in charging. Now, that being said, our competitors are not really fully committed upon high output and high accessibility, something ChargeBay really focuses on. The fact that we won't be limited to one charging network and just charging alone is what will provide more value to EV users. Comparing our pricing model in the city of Tampa at the same cost spend, we were able to deliver 75% higher revenue, everyone, due to our proprietary algorithm.
In the terms of gaining critical mass in our target cities, ChargeBay would initiate its pilot program as we have done with our regional brand. This would allow us to install chargers at high traffic areas, which would increase visibility of the brand and create more buzz for ChargeBay. With a target base of 50,000 users, our operational costs will be well within our revenue, allowing us to secure an annual EBITDA of $1.4 million.
Now, that being said, apart from traditional growth strategies, we also have synergies proposed by leading charger manufacturers in the industry that have 600 installation partners around the US, and that can help us acquire thousands of new leads each month in a mutually beneficial understanding, of course. In just 4 days of launch in just one city and near zero marketing efforts, we were able to secure 250 plus signups, 5 hosts, almost 5 transactions, and an NPS rating of 9.7.
For the energy transition, we would allow decarbonization of transportation by increasing the incentive of Americans to switch to EVs. By allowing anyone to create a public level 1 or level 2 charging station, we increase the accessibility of EV charging, allowing current EV users to travel more. For equity and environmental justice, we fill the gaps where other networks are reluctant to expand. Because anyone can create a public charging station, anyone can use an EV.
Now, where is ChargeBay right now? Well, we are trying to raise a pre-seed round to employ and deploy a production-ready app that will provide higher convenience and higher usage for hosts and users. And we are also going to TechCrunch as a part of top 3 early-stage companies from 3,000 early-stage startups. So, guys, are you ready to evolve with EVs?
Can you help me understand a little bit more about the the supply side? How many people have room in their driveway for their car and an EV charger and space? Like, what kinds of examples are you looking at? Are you really expecting this to be a multi-unit residential?
It's a network effects business, so we would have a host side and user side, right? The host side, again, I always say this, not all homes are on Airbnb, so there are going to be a few people that are going to be residential charger, mainly at locations where there's, can you pull up the Tampa host site?
Yeah.
Mainly at locations where there's a higher footfall area, like we went to Tampa and so these areas, these have stadiums, amusement parks, theaters, and they have also residential places right in front of them. They can come in and park there. And it's all not just residential places, it's also commercial places. Like if you have a salon, a movie theater, a restaurant, you would want more customers to be discovered through the app because we would have a subscription model. Now those customers would be bound to use the app. So they would want to go at a place where they already have a charger.
Right, and can you talk a little bit how you're going to ramp the supply and demand in a given geography?
So we are currently in a pilot program, and we have installed 5 chargers as well, apart from the 5 hosts that we already have, to create kind of a push. Like it's a chicken and egg problem. You won't have users before you have hosts. You won't have hosts before you have users. So we have to invent the egg basically, and we are inducing that in the economy, seeding that in. And people are going to people are going to see that visibility and then use and then also onboard.
And that's why we have the synergy with existing charger manufacturers so that when they have installation partners, if the host is interested in gaining revenue from their charger, it would allow them to sign up on the app. And
yes, they have a centrally controlled charger as well that they want to give us the API for, and our network can host that.
So it sounds like you're describing a 2-sided marketplace with an app interface for end users.
Yes.
Am I summarizing that correctly?
Yes.
Okay.
That was a good final question in 8 minutes.
Yeah. Good question.
All right. I am going to use a microphone, because by the end of the day, I would have no voice. So thank you so much. We're going to give the judges a moment or two to make some notes, and then we'll have our next team come up. So our next team is going to be COMPScan, and I think I did have one comment about the electric vehicle dealerships and how we have to be more clear in the questions that we ask them now. I walked in the other day and I asked, how much do you charge? But they didn't know what I meant. All right, that's the only joke I have about electric vehicles. There's probably more. Thank you, thank you. It's gonna get very old by the end of the day. I'm 28 of these things. But we have to kill some time. Something else I'll also say for all of the students who are here, we will be handing out a final sort of feedback form. I know we've asked for your feedback along this whole process after the Explore events on some of the submission forms. We have a paper copy. We will have a QR code as well, but we do want to hear what worked, what didn't, what could we do better in the future, as well as sort of any takeaways that you have about this program. Because we're funded by your tax dollars, because we're funded by the federal government, we want to make sure that we continue to improve, that we continue to deliver value if we do this again in the future. So your feedback really does help us make this better. I'm looking forward to receiving that from all of you. All right, judges are mostly looking up. And so our next team is going to be Energy Auditors from Texas A&M presenting COMPScan, diagnosing and retrofitting compressed air systems. This way and that.
Good morning.
Howdy. And we are COMPScan, and we make affordable compressed air diagnosis and monitoring system for compressed air systems targeted towards small to medium-sized manufacturers in the US. My name is Dan, and we're thrilled to be here today, and joined by me are my colleagues, Teksu, Digvijay, and Erica. And as part-time PhD students and full-time PhD student and part-time energy auditors, we're excited to present COMPScan. So we want to go over, first of all, what is compressed air? We've all seen compressed air in a can like this to do useful work, such as cleaning our keyboards. But similarly in the industry, compressed air is used very widely, from powering small hand tools all the way to large CNC machines.
All right, so let's begin by diving into the significant issues that small to medium manufacturing, or the SMM, are facing. Inefficient compressed air system and lack of affordable solutions to mitigate these inefficiencies. Compressed air systems are notorious for driving up the energy bills, with $29 per MMBTU compared to other resources. Also, compressed air consumption accounts for 10% of industrial energy usage, which is equivalent to 0.1 trillion kilowatt hours annually. Also, more than half of this expensive resources gets wasted through leaks and other inefficiencies without the knowledge of facility managers. As we mentioned, we are DOE certified part-time energy auditors for SMMs in Texas. With over 35 combined experiences, it was clear to us there were lack of affordable diagnosis and retrofit solutions for the compressor systems in SMMs. In our experiences talking directly to the SMMs, there were lack of awareness, oversized system, challenging leak detection, lack of monitoring capability, and lack of capital.
Looking at the market size in US, we have approximately 617,000 small to medium-sized manufacturers, and 85% of them use compressed air in their daily applications. Although there are DOE-sponsored energy audit, it only covers facilities that are within 180-mile radius and with a restriction on the size of utility bills, and less than 3% of manufacturers avail such service every year. So COMPScan has developed a retrofit package consisting of web-based data acquisition and off-the-shelf sensors. It collects logs and monitor data from air compressor all the way. Sorry, it collects logs and monitor data for the air compressor without affecting the production. Our in-lab test algorithm will help generate insightful information that will be shared with our customer on a regular interval that will help them enable to diagnose their energy saving solutions. Now, looking at the level of data needed, we have product A and B. There are 2 tiers of monitoring and diagnosis available. And with product C, we want to provide a consulting service that will help to design and commission the energy saving solution all the way to implementation. Now, as you can see on the left plot, this is how our product portfolio looks like in terms of solution comprehensiveness, customer base acquisition, and cost. Product A focuses on minimal diagnostic using basic sensors that will help to reduce the cost of product A, and with that will help us market penetration and reaching even smaller facilities. Product B is targeted to the facilities that will have moderate to high potentials of energy saving. And with product C, we want to target the manufacturers that have significant problems around the compressed air.
Right, so now let's turn our attention to the competitors in the markets. As you can see on the right figure, COMPScan is better than other competitors in terms of price and plug-and-play feature for any compressor brands. Our competitor analysis reveals that although they have similar features, they often come with high initial costs, complex installation steps, compatibility issues, and lack of insights on energy savings. COMPScan's impacts extends beyond just the cost savings and the competitiveness. It potentially benefits 617,000 SMMs by letting them control their energy usage and drive sustainable growth through energy saving of electricity that can power up to 2.6 million households per year, and energy transition by reducing the CO2, which is equivalent to planting 1 billion trees. And lastly, equity and inclusion by lowering the financial barriers for the underserved SMMs.
So here's our marketing sales strategy. We leverage both conventional ad campaigns as well as targeted outreach to get to the decision makers and facility managers that are becoming harder and harder to reach. Here's a cost breakdown as well as a revenue stream of our business. We have a operating cost, fixed cost that will go into development of software as well as excellent customer service. And the variable cost that will go into development of hardware. Yeah, as you can see on the right, we have two streams of revenue. First one being the product sales from product A, B, and C, with unit costs of $850, $1,850, and $15,000. With second stream of revenue from product C, commission cost, with overall average profit margin across all of our product around 20%. Our KPI, key performance indicator, painting a picture of COMPScan's growth. By engaging with customers from awareness all the way to retention, we have a break-even point of 1.5 years with initial capital requirement of less than $2 million. Lastly, this timeline outlines a strategic roadmap to our market penetration and expansion. And in conclusion, COMPScan offers a comprehensive compressed air solution for small to medium-sized manufacturers in the US. I thank you for your time, and I'll take any questions. Thank you.
So in the case of product A and maybe even product B, you've got a small manufacturer that has a lot going on. What's the so what for them if you're not actually helping them know how to fix it? You're just telling them they have a problem. And how do they do the ROI equation that says, hey, it's worth getting this update because I know what to do with it and I'm going to save money or carbon or.
Yeah, that's an excellent point because a lot of manufacturers use compressed air, but oftentimes they don't even know where compressors are located because it's tucked away on the outside on a far corner. And there are far less facility managers we have seen during our audits. They know how much energy is actually using. So we figured first step will be to roughly estimate exactly how much they're using, how much they're wasting. That's with product A. And the benefit of that is since it's so economical and we can ship it anywhere, it can reach to far beyond the conventional energy audit radius of just 180 miles around the where energy audit is conducted.
But if I'm a facility manager, I'm going to pay you to tell me how much I'm wasting and then not have an answer to what to do about it. My boss is probably not going to love that.
Right. So we have a product portfolio that takes you along that step. So product A is to give a rough estimate. Product B is designed to do a detailed analysis of what they have going on and what's wrong with it, such as if the compressor has low efficiency, if the intake air is too hot. It's designed to make root cause analysis basically.
But then I've got to pay more to actually get the answer to what to do.
Right.
I'm just trying to imagine why anyone's paying for product A. We can leave it there. I don't want to spend too much time on one question.
Since this is a product that will be sent out, we can potentially retrieve it back. Since we can use the product over and over again, the cost of analysis is so low. It's just basically paying for cheap sensors. They could potentially be reused and shipped back. So you essentially have to just pay for the shipping cost. And I think that's a pretty low initial investment compared to thousands that are being wasted every year. So I think there's a huge upside to explore what they have going on with product A.
All right, thank you so much. All right, let's see. Okay, so I do have one very awkward joke about factories that make okay products. They're called satisfactory. All right, it's getting older as we go. All right, so our next team is going to be HeatVault, which is from Georgia Institute of Technology. It looks like the judges are almost done making some quick notes, and then we will have you guys already here, which is awesome. I'm looking for eye contact from the judges, but otherwise we'll go there. For all of you who are here as well, I think it's important to note that as you listen to people talk, there's a wide variety of backgrounds, expertise, perspectives, and whether or not there's opportunities in entrepreneurship, in small businesses, in the investment industry, at the Department of Energy, with the federal government. We hope that you'll take whatever you learned in this process forward and keep it in mind as you look for more ways to address our energy transition. And with that, I'm seeing some eye contact for the judges, so I'll turn things over to HeatVault from Georgia Institute of Technology.
Good morning. Thank you. We're HeatVault. I'm Rohan.
I'm Rahul.
Representing the future of data centers. And it may be closer home than you expect.
So HeatVault is an edge data center developer. Edge data centers are a subsector of the data center market, and they're data centers with a smaller footprint that focus on proximity to urban centers / the origin of the data request. That's really important for time-sensitive data processing. So think applications like autonomous vehicles, 5G, medical devices, industries where milliseconds of latency make the difference. So it starts with our data centers. What makes us different is that we leverage heat recovery technology as a service. We recover heat generated from the computing process and use it to heat nearby buildings, removing their need for natural gas, saving them money, and helping them reach their sustainability goals. In return, the building gives us access to their facility for space. So the heat is essentially our form of rent. And because we target buildings in urban centers, we're then able to provide edge data center capabilities to clients in those industries that I mentioned, and the building can pass on reduced energy cost and an environmental alignment to its tenants.
So, in a traditional building, the heating relies on boilers. They burn natural gas, creating steam heat, which is transferred through a heat exchanger to warm the building. While this has been status quo for decades, these systems are carbon intensive, expensive to build, and because of high operating temperatures, inefficient and difficult to maintain. Our system uses data centers as the heat source. The heat emitted by the data center is captured by a multi-segment heat exchanger. This technology allows for efficient capture and recovery of heat at low temperatures. The heat that's transferred can then be used to warm the building, even using the same water circuit. It can also cool the building using absorption chillers, allowing us to operate year-round. So let's zoom in on what's actually generating the heat. In our data center, we have thousands of GPUs, or graphics processing units, which generate a lot of heat. To ensure they don't melt or degrade, we use liquid cooling technology, specifically microelectronics cooling units, which are direct-to-chip plate coolers that can be up to 1,000 times more efficient than air cooling. And the hot water that leaves the unit is our heat source.
So in sizing the market opportunity for this technology, we've identified a total addressable market of $57.2 billion, representing the overall data center market. We have a service available market of $13.2 billion, representing the edge data center subsector, whose growth is expected to outpace that of the overall market. We have a service obtainable market of 30% or $3.96 billion, which we think is reasonable given that we solve the industry's main pain points and we do so inexpensively. For instance, we see a strategic real estate shortage. There's limited undeveloped urban real estate and it's expensive. We solve this by integrating directly within new and existing developments rather than competing with them for the same space. Data centers can also have a very negative environmental impact. That doesn't align with many client sustainability goals and is under threat from regulatory scrutiny. However, by electrifying the partner building's HVAC system, we save tons of carbon per month, helping ensure that we're safe against future regulations. There's currently no competitors in the market that leverage this heat recovery technology, but there are other edge data center developers. For instance, there's DartPoints, which builds independent facilities in the city, but they're susceptible to that real estate shortage that I mentioned. Next is American Tower. They build data centers at the base of their own cell towers, but they have limited expansion potential as they only own so many cell towers in near urban cities. Last is Edge Centers, which build solar-powered data centers, which is great for the environment, but has a very large footprint and can never truly be integrated into the city. Looking more closely at the financials, it's difficult to get specifics in our industry because the costs of development are very client-based and depend on the facility's previous infrastructure. We used Coda, a 21-story Georgia Tech high-rise, as a case study. Coda spends $67,000 per month on energy. With HeatVault, they could save up to 50% of that, as well as hundreds of thousands on no longer needed equipment like boilers. That corresponding reduction in energy usage would be about 253 metric tons of carbon per month. The space we need would typically cost about $48,000 per month, but that's money that we don't spend because of our partnership with the building. So we're located in the heart of Midtown Atlanta and able to charge a premium price for that location without a corresponding increase in our costs.
Facility setup has a wide cost range, but it's subsidized with a 26% tax credit because we leverage heat recovery technology. Operating costs are covered by the client, as is industry standard in the data center market.
Another key impact of our technology is its effect on energy affordability. Here you can see the severe energy burden faced by lower income families. They can spend up to 16% of their income on utilities. By integrating HeatVault technology, we can provide affordable heating solutions to these families, reducing their energy burden. We're paving the way for equitable and sustainable development, converting data centers from urban challenges to urban solutions. Thank you.
We have 2 minutes for questions.
So I know you said at the beginning that your heat recovery is a service, but obviously providing the edge data center is part of what makes the business model work. Do you already have partnerships with the parties that are actually going to install the data center, or is that part of what you're offering?
Yeah, so we are the data center developer, so we're building the facility.
And the heat
Yes,
and cooling system.
We're building the facility, and then the manner in which we build the facility is leveraging the heat recovery technology. So we are sort of that installer that you're talking about.
And is someone else running the data center then, or are you also doing that?
No, so we're also running the data center.
Right, so you've like multiple different business models going at the same time.
That's pretty industry standard for the data center developer to also maintain the facility and.
Right, but not to also run an HVAC kind of company, right? You're also doing that.
So we're not necessarily running the HVAC system of the building. We're simply integrating our heat into their system. So they already have a heating system for their building. We're simply building the piping and sort of.
And sending the heat that direction. Yes. Okay, or are you also doing the chilling?
Yeah, so that depends on building infrastructure. Absorption chillers are technology that use waste heat instead of electric power for the compression in systems. So if that's a technology.
If the building has that, you can facilitate that, but you don't provide that.
Yes. Okay. So our main target is new developments. When we partner with new developments, we can sort of create that infrastructure with them as they develop.
Okay, thanks.
Great job, guys. Couple questions. The multi-segment heat exchanger and the microelectronic cooler, I'm just gonna call it that. What scale have they been tested at?
Yeah.
I'm assuming they're not commercially deployed yet,
right?
Correct?
So these are both DOE lab technologies, and they're around technology readiness levels of 5 to 6. So they've been tested ad nauseam labs, but they're still being scaled in these applications specifically.
So thank you very much. All right, so to kill time between these two presentations, I've been tasked to check the microphones because I hear one might not be working. That one's working. This one is okay. I think that one's okay. This one, is that one? All right. How about that one? Yeah. You just use that one. I think it's okay.
Yeah.
And that one. All right. No jokes this time. I got one. What was the baby computer's first word to its father? Data.
I'm good without.
All right, without a mic. All right. So next we have Flow Solutions from University of Pittsburgh and Carnegie Mellon University. Welcome.
Thank you. Hi everyone, my name is Becca Siegel and I'm the CEO of Flow Solutions. My PhD research is focused in flow batteries, and we make flow battery monitoring and diagnostics to unlock our energy storage future. 50 times by 2050. That's how much more energy storage we need on our grid to meet carbon emissions goals. We have an opportunity to put millions more batteries on the grid to create reliable electricity for everyone. And it's not going to happen with lithium-ion batteries. Lithium-ion is something you see in your phone or electric vehicle, and it's also being used in short charging times on the grid. However, as we can see, the price does not change as you store more energy. And for our grid, we need the cheapest battery possible. The flow battery has decoupled energy and power, which means it becomes 10 times cheaper as you store on a citywide scale. Also, flow batteries are predicted to take over half of the energy storage market by 2050. They're even in high demand today, as we see from prominent flow battery company ESS being completely sold out of their systems in the next 2 years. So if we want to prepare for tomorrow's reliable electric grid, we need to be looking at making more advanced flow batteries to solve some critical challenges in the field, such as poor data management and diagnostics, and inaccurate sensors and monitoring, leading to the challenge that flow battery manufacturing cannot support big data analytics, causing shutdown from unexpected failures. And the risks are massive. The risk of shutdown is a citywide blackout, or hospitals and data centers being completely shut down, affecting underserved communities the most if there's no electricity. And that's where we come in. Our Flow Solutions Toolkit unlocks the potential of flow batteries through our diagnostic software with predictive performance modeling to improve efficiency and extend the battery lifetime, and with our sensing hardware. Here's a prototype on the stage here, novel sensors with enhanced sensitivity and accuracy. And so we're able to not only identify failure in batteries, but we can predict when it will happen and stop it. Flow batteries is the fastest growing market in energy storage today, and we plan to enter at the $1 billion flow battery software. Our serviceable addressable market is the $23 billion growing flow battery manufacturing space. And our mature flow battery diagnostics is our total addressable market at $45 billion. We decided to start Flow Solutions because through our 130 customer discovery interviews, we found that our competitor solutions are inadequate. And so we decided to go into localized sensing, big data infrastructure, and flow battery expertise so that we can provide the ultimate toolkit for our customers. So let's be clear, the flow battery market today is small. It's growing, but it's small, and we're interested in connecting with those who want to join us now and ride the wave as the market explodes into a $100 billion size, with diagnostics taking up a significant portion of this at $45 billion. This is actually a pretty similar ratio to what we see in lithium-ion batteries today. There's many different monetization opportunities for us in diagnostics, looking at selling diagnostic software, selling sensor hardware, and selling battery data. And we plan to capitalize on all three. Some key milestones for us began with customer discovery and proof of concepts. We're now looking at forming pilot partnerships and launching our minimum viable products by this summer. Some of the companies here make up our 9 letters of intent. And our next launch will be selling software as a subscription model. Here are some of the companies that we have ongoing conversations with. It's important to note that we're talking to leaders in the field of flow batteries and other battery technologies, which helps us de-risk our business model. Our next launch is selling sensing hardware to these same customers already acquired, leveraging customer trust. Now, we don't just want to be the ultimate flow battery diagnostics company. We want to help set the standards for implementing energy storage into the grid, which is why our final launch is sensor data licensing, partnering with grid managers who need this information for next day energy markets, and becoming the compliance standard by partnering with Underwriters Laboratory. Our exit strategy is acquisition by a battery manufacturer that finds us most valuable. And here is the team that makes this dream of energy reliability a tangible future. I'm Becca from the University of Pittsburgh, and I have 7 years of research experience in flow batteries. Our other team members have deep expertise in software engineering, batteries, and in energy markets. So together, we have an opportunity to connect millions more batteries to the grid to create reliable electricity for everyone. For customers, we can improve reliability and cut the cost of a battery. For the energy transition, we can prevent 100 million metric tons of CO2 from reaching our atmosphere. And for humanity, we can create more reliable electricity for everyone and support underserved communities. So we hope you'll join us in unlocking the potential of flow batteries through diagnostics and monitoring. Thank you.
So, I'm
just to give you guys more heads up of how much time that was. So it was 5:30, so we have 2 minutes and 20 seconds.
Great job, and it's really cool to see you doing so much customer discovery work. I'm wondering, in terms of what the customers are saying, what are the normal moments of failure that they might experience, and how does your solution address this specifically?
Sure. Yeah, thanks for asking that. One of the biggest problems our customers have is early stage failure in the first 3 to 5 years of the battery system, even though it should last 25 years. And to answer your question, they don't know why it's failing. That it sounds crazy when you think about it, but they don't have the insight using sensors that understands the sorts of degradations that they expect. And so to go deeper, there's different types of degradation with the battery electrode, there's crossover, there's pumps that are just being flooded, and they aren't able to identify that. So through our sensor platform, we can identify failure that is occurring very early on.
So it's not just the membrane, there's also some hardware components.
Yeah, it's mostly hardware actually for flow batteries.
And so can you talk about what's unique about what you're offering? Because it feels like if this is an early industry and they're failing a lot, that the manufacturers would have pressure to actually develop their own tools to actually identify what's going on in order to get market adoption. So why aren't they doing that? What's unique about your solution?
Yes, so they are doing that. Internal software teams are part of our competitors. However, they are focusing more on getting their batteries into the market and developing chemistry. That's what they do best. And so actually, they told us that they would rather have us do their diagnostics for them instead of doing it themselves.
So it's a skill set difference, is what you're saying, or sort of a focus area?
It's a skill set difference, and it's an issue of money. It's not worth the money for them to do it themselves. They'd rather have someone else do it.
20 seconds.
One more.
What does it cost on average when there's a failure?
So the costs are $25,000 per year for operation and maintenance. And so it takes up the majority of that.
So one failure would max out what they budgeted for the year.
Yes.
Awesome. Thank you very much.
Thank you.
All right, so I have a riddle for you all while I make some notes. I am not alive, but I can die. What am I? I am not alive, but I can die. Fire. Fire? No. Batteries. Batteries, what I was looking for. Most of my jokes are trying to relate to what the team was that was prior to us, so that could be a clue, I suppose. But see some notes happening. And our next team is going to be Ion Clean PV from Hawaii Pacific University. Welcome.
Aloha! This is Ion Clean PV, a waterless, touchless, electrostatic PV cleaning solution. The solar energy sector is growing rapidly in line with the UN plan for net zero emissions by 2050. This growth pushes for the need for robust solutions to ensure optimal performance for installed PV or photovoltaic panels, while also being environmentally friendly. Excessive soiling on solar panels reduces energy output and efficiency. However, current cleaning solutions and methods for panels use about 10 billion gallons of water every year, and chemicals that harm the environment. To put that into perspective, 10 billion gallons of water is enough drinking supply for 2 million people. There must be a more sustainable solution that maintains peak energy production without harming the environment.
My name is Matthew, joined with my colleagues Brandon, Madison, and Clarissa, and we are here to bring you our solution, Ion Clean PV.
Ion Clean PV is an electrostatic PV system that operates on the principle of Coulomb's law, eliminating the need for water and preventing damage to solar panels. It is a trailer-mounted mechanism that holds an agile robotic arm coupled with corona nozzles that negatively charge dust particles. Then a negatively charged plate electrode repels these particles, effectively and safely removing them from the surface. We advocate for ease of use, minimizing manual labor while conserving water.
Our target market consists of two groups. First are utility-scale solar projects, which comprise of large and small PV farms with small farms being able to generate up to 400 megawatts daily and larger farms being able to produce even further beyond that. Second are PV cleaning service companies, which do traditional cleaning services. By integrating our device, our Ion Clean PV will be able to alleviate manual labor costs while providing more resource-efficient solutions.
These are the companies that hold major market shares in today's PV cleaning industry. Sunbrush Stack Flex is the leading choice for equipment, choice for solar panel cleaning. RST and Heliotex are both automated water cleaning systems. Let's now analyze what the PV industry is already paying to keep their panels clean. On your left is the total amount of water wasted, the total amount for 4 units of Sunbrush's Track Flex, total amount of labor to run the entire process, and the total cost for deionizers and skid steers. It equates to about $1.49 per panel. Let's compare that to Ion Clean PV. On your right, 0 gallons of water wasted, savings on units of Ion Clean PV, savings on labor costs, and $0 wasted on deionizers and skid steers. The cost to clean per panel using Ion Clean PV is 83 cents per panel. Money talks, people. By switching to our solution, Roadrunner Solar could save almost 50% on PV cleaning. And not only that, 150,000 gallons of water could be better used elsewhere.
So a single unit of Ion Clean PV consists of 3 modules: the Corona nozzles and frame, a robotic arm, and a towing vehicle with a trailer. The estimated production cost of the Corona nozzles and frame is estimated to be $15,000. The same goes for the towing vehicle and trailer. An average aftermarket price of a robotic arm that is capable of wielding the nozzles costs $20,000, leaving us with a total production cost of approximately $50,000. With a 50% profit margin in mind, a direct sale of a single unit of Ion Clean PV will total to $75,000. The following project stages highlights our revenue model, and the goal is to raise a total of $3 million for R&D, pilot demonstration, and product launch by the end of 2026. After Ion Clean PV successfully penetrates the market, the next phase is to focus on securing cost-efficient, long-term leasing contracts, ensuring a steady revenue stream. From there, we allow direct sales to our customers, giving them full range of use and freedom to integrate our device into their operations. This is where we expect to grow our revenue. Finally, we expand our reach, using Ion Clean PV in other applications that can contribute toward the expansion of the solar industry.
Ion Clean PV can also waterlessly and touchlessly clean heliostats, parabolic troughs, and even floating PV. The pain points of labor use would be heavily reduced, and water use would be completely eliminated. As part of our commitment through Ion Clean PV, we aim to promote equity and inclusion by means of employment opportunities. For local impact, for example, back home in Hawai'i, we hope to provide job opportunities for members of marginalized communities that suffer from poverty due to job loss during the energy transition. For regional impact, Ion Clean PV's waterless cleaning technology will be able to conserve critical water supplies in water-stressed states like California and Nevada. For global impact, our waterless cleaning solution produces a significant environmental impact by providing a sustainable cleaning solution in countries facing severe water shortages, like in the Middle East and North Africa. Mold, dust, dirt, and other materials lying on top of the panel can impede the PV cell's ability to dissipate heat efficiently. So once the temperature reaches 65 degrees Celsius, as you can see on our graph here, the module will experience a loss of 15%. Ion Clean PV prevents this loss. PV panels also have an average lifespan of about 25 years or more. Regular cleaning and maintenance are required to preserve that lifespan. And also to reach, it is required and essential to reach that 30% goal that the US set for electricity generation by solar by 2030.
All right, thank you so much. And we have 2 minutes for questions.
Great job. Great job. 2 questions. I see this arm and it's doing something to panels. My first thought is, could it damage the panel if something goes wrong? And what do you think? What do you have a plan for that? And secondly, some of the panels are fixed, and I would be afraid that it would get it off of its angle, which would then decrease, their efficiency as well. So those are the two thoughts I had.
Thank you. To answer the first one, our solution is touchless. So it's only hovering over the panels. There is no touching whatsoever. So that lessens the damage done to the panel itself. Traditional cleaning does use brushes, physical contact, destroying the coating on the PV panels itself. So our solution gets rid of that chance altogether.
I guess I have a related question though. What percentage of existing solar farms and installations actually have room in between the panels for a trailer going through with a robotic arm? It feels like, certainly rooftop installations and other kinds of installations aren't going to be suitable for that. So I'm just trying to get a sense of, what percentage of the market you think you can, or do you have to have people deploy differently in order to have room for these, trailers, et cetera?
Thank you for that question. From this infographic we have, this is a small unit, and from the photos you see of satellite photos of solar panels, they seem very tight and close together. They're really not. There is space for maintenance work, and that's where we come in. It's not that tight as you might think it is. And as far as other PV panels, I know some are bi-directional, so they can tilt and give us more room if necessary, but we don't see it as an issue.
Awesome. Thank you so much.
Thank you.
Thank you. All right. All right. So I think we just invented something here today as well. As the judges were all discussing solar, we just create a solar panel show. I used that one last year too. All right, we're making some notes, and our next team, I believe, is PCM Carrier Manufacturing from the University of Colorado Boulder. So we'll bring up their slides. Looks like Jackie's working on that while our judges make some notes. And grab a microphone, go for it. And that looks like your slides.
Sure. We've all seen a truck like this on the road, but few of us probably realize how truly important it is to our way of life. 8 out of 10 food products you eat will at one point have been on the back of a refrigerated truck, just like this. But that need comes at a cost to both the environment and to the trucking industry. In the US, the transportation sector beats out every other sector, to include power generation and commercial industries, as the #1 polluter of greenhouse gases. And in terms of cost of the trucking industry, 28% of annual trucking costs are fuel expenses. And just 2 weeks ago, the EPA finalized a major legislative mandate moving the trucking industry towards net zero emissions starting in 2027. This is driving a massive demand for innovation and modernization across nationwide trucking fleets. We want to be a part of that solution to decarbonize the trucking industry. We are PCM Carrier Manufacturing, and we create superior insulation for the refrigerated trucking market in order to reduce fuel costs and carbon emissions. And I'll be followed by Laird, who will tell you more.
So let's talk the refrigerated trucking market. These trucks have two main components that are different than any other trailers that you see on the road. One of them is going to be the AC unit on the front of the truck. This is known as a trailer refrigeration unit, or TRU. These TRUs consume up to 40% of all the fuel on these semi-trucks. So the other main aspect of these refrigerated trailers would be the insulation. We've identified phase-changing materials, or PCM for short, as a salt-based solution to be embedded into the insulation on these trailers. By embedding this into the insulation, we're not changing the size requirements of these trailers at all, and we're only decreasing the weight carrying capacity by 2% roughly. So this graph right here is pretty important. What we're showing is the temperature change inside the trailer over time. The red line shows the polyurethane current standard of insulation, and what I want to draw your eyes to is the two peaks in the middle of the day here. So as the day gets hot, the temperature in the trailer gets warmer as well. By adding PCMs to this trailer, seen here in the green line, we're effectively reducing those peaks, which means that we have a superior insulator, which means less fuel going to be used. And in terms of the fuel reduction, we're talking a 30% reduction in the TRU specifically, which translates to a 12% reduction annually for each of these vehicles on the road. I'm going to pass this off to Eric, who will go through our business model.
Thank you. So our model offers two value propositions. The first are our customers, and then the second is their customers. So our customers are refrigerated trailer manufacturers. So we will be selling them prefabricated PCM panels that will be inserted while the trailers are being manufactured. Ultimately, based on this price premium, we expect them to be able to increase their profits by 34% because of that. So their customers or end users are reefer trailer drivers and owners. So based on the fuel reductions, we expect them to be able to increase their profits by 9.3% annually just because of this passive system. Ultimately, because the end users value, we feel like the markup is justifiable in the end. So while it costs $2,000 for our customers, we expect it to cost $1,000 for us. We have a large market size. We conservatively estimated our profit margin to remain constant over a 10-year period, and our market penetration by year 10, a baseline expected at 25% to remain conservative. Our concept to market timeline is 3.5 years. Our go-to-market strategic partner would be working with Thermo King, the largest U.S. manufacturers of TRU and the most innovative in the industry. And our intellectual property partners will be working with the University of Colorado Boulder. So while we view our current competition as insulation itself, polyurethane, in terms of where PCM is being applied currently, there are two active verticals. One, which is ocean freight, and the second, which is scientific and medicine equipment being transported. So ultimately, that gives us first mover's advantage into the reefer trailer market, and we feel great about that because frankly, that gives us the opportunity for uniquely creating IP that's developed around design, process, and chemistry. So this would actually give us a competitive defense that anyone who want to enter into the market post, and ultimately, we feel it can give us the advantage to be able to produce the cost lower than manufacturers themselves will be able to do in the end.
So now I'll cover just a few additional impacts of our tech beyond the business model. The greatest of which is probably its application in the pharmaceutical and agricultural sectors, who are heavily reliant on reefer trucking to function. So by reducing fuel usage, we reduce their Scope 3 emissions. That reduction in fuel usage allows for a faster adoption of alternative energies and other clean tech. The reduction in energy usage puts less pressure on other inputs to the innovation cycle in the reefer trucking industry. And last but certainly not least, the positive effect to disadvantaged communities. So 1 in 5 Americans are living in close proximity to trucking routes and therefore are exposed to higher levels of harmful pollutants. So by reducing fuel usage, we reduce emissions and minimize some of the negative externalities caused by the trucking industry on these disadvantaged communities. So to bring this home, we believe our product delivers a triple bottom line. For trailer manufacturers, a net profit increase. For trucking operators, we see fuel savings. And perhaps most importantly, CO2 emission reductions. So we think the triple bottom line for the product speaks for itself. Thank you.
We have 2 minutes, 10 seconds.
Great job. Is this only for new trailers, or could you also retrofit existing trailers?
So to speak to that, so our first approach would be focusing on our beachhead market would be new reefer trailers that are being manufactured, but secondary we focus on retrofitting, followed by final mile transport, which is focusing on box vans and dry vans, reefer vans, and box trucks. And then following that, we'd actually like to move into the ocean freight and rail industry.
Maybe I'll follow up on that exactly. So you don't have to go to the competitive slide, but going back to that concept, why is it that the ocean reefer and the other competitors couldn't just easily move into this? It feels like a rectangular truck doesn't require a lot of IP to put panels in there that I'm not understanding. And similarly, you mentioned that you're going to be able to preempt the manufacturers and be more cost effective, but I didn't hear anything about your IP as to why you'd be able to do that.
Sure.
Yeah, so that question actually has quite a few parts to answer, I think. But
well, you don't have long, so you have to be speedy.
So basically, the pace of innovation within the trucking industry is like traditionally very slow. It's hard to show a value proposition to the end user that really makes them want to buy a product like this, even if the numbers all work out. And lots of the innovation in this market has mostly been focused not on the installation, but on trucking route optimization and or generation of the power source, so like ETRUs and things like that. And the significant cost of development of this technology, because you really do need a PCM or some sort of material that is tuned to the transportation temperature that the truck runs at, right? So it's a different temperature than something that is in ocean freight or in like railroad applications, things like that. So that cost, both monetarily and time-wise, is a large obstacle. But with the mandate from the federal government on the EPA, on the Clean Trucking Initiative, it does create that pull to get operators to see this value proposition as something that would really benefit them.
Thank you so much. Alright, so the joke for this team is, why didn't the traditional trailer have many friends? Because it wasn't cool enough. So maybe they could fix that one. All right, so our next team is going to be Team Carbon Busters from Purdue University. So the judges are making a couple notes, but come on up, we'll get you guys settled and make sure that we see your slides. Let's do. Oh, there it is.
Understand wearing all the hats.
It's awesome.
You can switch to your hoodie.
Yeah, no budget operation.
Very efficient.
All right, I think the judges are just finishing up some notes, so when you guys are comfortable and you see your slides, you can get going.
Greetings, we are team Carbon Busters. Our carbon negative algae oil feedstock enables net zero biofuels, which is currently an untapped market worth 20 billion gallons per year. For the ease of judging, we developed EnergyTech Zpryme. Our intent is to show how we should score a 6 out of 6 in all the categories, plus the bonus prize for FECM. Let's start with technology identification for $600.
I got this. Our process is straightforward. We grow algae, then we extract the oil using our patented process, and we produce carbon negative algae oil feedstock. This is sold to our customers who make net zero biofuels for unelectrified vehicles, like sustainable aviation fuel and renewable diesel for medium heavy duty trucks. We should score a 6 out of 6 for 2 reasons. First, we are dual purpose, and second, we are lower cost.
Now, market assessment for $800.
I got this. Our customers are US biofuels producers whose pain point is the fact that there are no carbon negative feedstocks available. Algae oil is a commodity, competing with soybean and corn oil that are carbon positive food sources and require subsidies. We should score 6 out of 6 for 2 reasons. First, through our 200 million gallon per year offtake agreement, we secured our customers, and we verified product solution fit through ICOR.
Economic feasibility for $800.
I got this one too. The market price is $7 per gallon for algae, corn, and soybean oil, but our cost of production is only $5.50, which is at least 45 cents below that of our competition. For financial sustainability, CapEx is $50 million with 20 million equity, IRR estimated over 30%, and payback in just 2 years. We should score 6 out of 6 for 3 reasons. First, through our 200 million gallon per year conditional offtake agreement, we can get number 2, $1.4 billion, which makes us a unicorn company. And number 3, all of our estimates were validated through NREL. To answer a question from the judges, feedstocks and biofuels are purchased based on price with per gram of CO2 reduced. So shown right, you can see that our $7 algae oil gallon is reducing the equivalent of 4 gallons of corn oil, which is $28. So obviously people will want to buy our algae oil.
Potential impact for $600.
I got this. For beneficiaries, our algae biorefineries are beacons of hope across the US. 20 algae biorefineries will create 30,000 jobs. And ladies, who wants equal pay? We do. That's why all our biorefineries will be gender equal. And 20 biorefineries capture 50 million tons of carbon over 25 years. For our role, we will start with biorefinery number 1 in Berkeley, Florida.
Then 19 more biorefineries totaling 200 million gallons per year. We should score a 6 out of 6 because 20 biorefineries will capture annually the same amount of carbon as all US EVs offset. Business plan for $1,000?
I got this. Our definition of success is to build algae biorefinery number 1 and then 19 more. For people and resources, this happens in 2 stages. For stage 1 resources, we submitted our SBIR grant application to commercialize our patent, which then will turn our conditional offtake agreement into a binding one. We should score a 6 out of 6 for 2 reasons. First, for resources stage 2, we've secured a letter of support for financing. And for our teams, for the people, we have the ideal teams for both stages. Our stage 1 team submitted the SBIR grant, and our stage 2 team is a C-suite of Purdue alum. To answer a question from the judges, algae biorefinery number 1 will require 1,500 jobs from Berkeley, Florida. Broward County has 30,000 unemployed people, so we can easily hire 5% of those who will then be trained by Brazilian biofuels professionals who train workers globally.
And now for the bonus prize for FECM for $1,000. I've got this, as we have already seen this before. We should win the bonus prize and score a 6 out of 6 for 3 reasons. Number 1, as we have seen before, our 20 biorefineries capture the same amount of carbon as offset by 100% of EVs in the US. And the second, our CDR is equipment-free and low risk. Because we're using algae, and this technology has been proven for over 200 years. Algae is Mother Nature's way of carbon capture. And third, 1 gram of algae captures 2 grams of carbon. We could bury the algae fiber underground, but since our business model is innovative, we are going to sell our algae fiber to Wilson, who will be making carbon fiber sporting goods with our algae fiber, thus giving us additional revenue. And now for the final jeopardy. Why now? We have learned these 3 lessons based on our previous studies, and we are going to make sure we'll be de-risking our project by not doing these. First, we'll have a smaller biorefinery size. Second, we'll have a diverse strain of algae. And third, we will be handpicking our location of algae ponds and growing them in Florida where they are native. Thank you, and we welcome your questions.
Thank you. And we have 2 minutes, 30 seconds for questions.
I'm curious if you also looked at technology licensing agreements, since it sounds like your IP is more in a solvent or a component part of existing facilities.
So we have a patent for the entire process. So right now we have an offtake agreement with the 2nd largest biorefinery in the US. And currently we are looking to, as we mentioned, we have the first biorefinery that we are looking to build and then expand it to 20 more biorefineries. So at this point, that is the next stage we're looking at, not the licensing side.
Great job. What is the current production of your technology? What have you been able to produce?
We are currently at pilot scale. So we are at a capacity where we can produce 1 gallon of the fuel. So we have an offtake agreement where once we get that 1 gallon, we can scale it up to commercial scale and produce, get to 10 million gallons by refinery.
So it's 1 gallon per day, I guess, is it? Or just 1 gallon per batch right now?
It's yeah,
per batch. Okay. So what is your plan for scaling to 10 million per year?
So as we have an offtake agreement with the biorefinery in the US, so we have a plan with them in which our technology will be used to get to a point where we can basically scale up all the equipment, and we are at a point where we can do a linear scaling to a commercial scale. I hope that answered.
Additionally, on that point, once we have like the 1 gallon and that on the slide of the business plan, our conditional agreement becomes binding. Like once we have that step, and then we'll also have like the binding letter of support for financing, and so all of those things like cascade that will then like give us all of the financial stability to scale up.
30 seconds for questions.
Can you say who that? Did you say who that contract was with?
For which letter?
The offtake, the big one.
Yeah, so that's like the 2nd largest biofuel producer. It's World Energy.
Okay.
10 seconds. Any super fast questions? If not, thank you so much. Good.
Okay.
Thank you so much. All right, so we're powering our way through these 10 presentations, and then we will have a break. We'll all run to the third floor, get a whole bunch of coffee, come back and do 10 more. I appreciate everyone's patience as we go through this. I'm really excited about all the ideas that everyone's presenting. So why did the farmer plant a light bulb? Hoping to get a power plant. They just get worse throughout the day. So our next team is Blaze Power from UCLA.
Hey, good morning, everyone. Most people keep saying that clean energy is the future, right? We want to transition to clean energy. People want to buy EVs, but we can't. What's stopping us from buying EVs? We have two major issues right now. One is that EVs are expensive, and EVs are expensive because the batteries that go into EVs are expensive. And two, range anxiety is a major issue. Let's look at how batteries are made. So we have mines, we have raw materials that go all the way through these 5 different steps. And we have the application, which is the final BMS that goes into car batteries. At Blaze Power, we have positioned ourselves in the midstream. So we do everything from step 2 to step 4. Now this process is broken in the US. Most of the battery companies that are selling batteries in the US are either Chinese, Taiwanese, or South Korean companies. And North American battery manufacturing is facing 3 major challenges. We have a supply chain dependence on high risk and toxic materials like nickel and cobalt. Battery costs are super high, and we have a complex manufacturing process in the conventional nickel and cobalt-based batteries. Now, our LMFP battery technology solves those challenges. We have secured the supply chain, so we have LOIs with mines, and we are eliminating the use of nickel and cobalt and incorporating iron phosphate chemistry. We have a breakthrough technology for 70% cost reduction in cathode materials, and we have a sustainable manufacturing approach. In comparison to the conventional nickel and cobalt-based chemistry, one of the major issues LFP has had in the recent years getting commercialized is that LFP is low on power density and energy density, but LMFP technology solves those challenges. It costs less, it's much safer, it has significantly higher production efficiency, and also high energy density. Let's look at the conventional battery manufacturing process. So we have several steps. We interviewed folks from gigafactories in Tesla and Panasonic that are making the cells. Making a battery pack takes anywhere between 20 to 24 hours. And this battery pack is super expensive. We have simplified the manufacturing process with a single step CAM material, which is cathode active material. And we are applying a carbon additive and heat treatment on top of conventional LMFP batteries. And this scientific mechanism for consistent cathode production has significantly shorter reaction times, uniform nanocoating, and micro sizes, as a result of which we require less energy, and we have a high recovery for solvents that go into cathode materials. We have a rapid process that shortens uniform coating composition, and we have double carbon coating process as well that also enhances efficiency further. Let's dive one layer deep into the carbon coating process and the electrode formulation. So we are using carbon black and graphite powder mix ratio, which has better ion transportation, and we have 40% reduction in NMP solvent, and we can reuse 90% of the NMP solvent. We also have a high solid weight percentage slurry, which saves time and energy. And these images that you see here are the scanning electron microscope images that we have taken in the lab. On the left side, you see the conventional glue process, which is inconsistent. And on the right side, you see our semi-solid process, which has high consistency in the lab scale. So right now we are at TRL4, and we are looking for lab partnering services at Lawrence Berkeley and at Argonne, which is the Access team, to scale the technology. Now, there are several benefits. One is that this is a North American IP. We fully own the IP, and we are planning to scale the technology. It costs significantly less compared to conventional batteries. It's more safer, highly sustainable, and has a significantly longer life cycle. So the batteries that we've tested in the lab have more than 90% retention over a 1000 cycle period. This also has a carbon reduction of almost 3 times in the lab setting. And as we scale the technology and apply this to gigafactory level, we'll have more than 5 times carbon reduction. And this achieves the breakthrough energy standard of more than 100 million CO2 reduction per year if we apply this at scale. Here's a breakdown of how we plan to scale the company. So this year we are planning for lab partnering services, and we are doing a 3 million seed round to build a pilot facility. Next year, we'll be doing a commercial scale, potentially a Series A, which is going to be roughly around 25 million. And in the phase 3, we'll be scaling the company either to partner with the Gigafactory or set up the Gigafactory ourselves. As we all know, the TAM for electric vehicles in the US is huge, and batteries are booming. So there's no shortage of TAM in this sector. And a go-to-market consists of EVs. So we are planning to launch with EVs, passenger and commercial EVs. And as we scale the company, we are looking for partnerships with energy storage systems, grid enhancing technologies, military and defense, and the government sector. So as of today, we have secured funding from UChicago, UCLA, and Massachusetts Clean Energy Center, the Mass Ventures team. Thank you.
And we have 5 minutes, so 3 minutes for questions and answers.
Okay, this might be a little unfair because I spent some time at Our Next Energy, which is a similar approach.
Yeah.
Can you say more about the competitive landscape, both in terms of other domestic solutions as well as the international solution providers?
Sure. So far we've interviewed more than 200 people for the market research. And one thing we observed is that there are less than 5 GAM suppliers in the US. So we have a couple of companies in the Bay Area and there's a couple on the East Coast. Most of the competition in the battery segment right now is in the anode sector, not in the cathode, and we are a CAM supplier. And when it comes to the battery manufacture itself, majority of the companies that we interviewed are either Chinese, Taiwanese, or South Korean, and we do not have a US battery manufacturer as of now.
So you're not doing cell manufacturing, you're just doing the cathodes?
We can do cell manufacturing. We have made battery cells in the lab. The reason why we are starting off as CAM supplier is because profit margins are high in CAM. We have up to 35% profit margin as opposed to cells, where the profit margins are between 5 to 10%.
Still have a bit of time for questions from anyone else.
I can keep going.
Keep going.
Okay, so you mentioned all these, larger markets. I'm wondering if in your 200 interviews, you also spoke to those end users in these markets.
Yes, yeah. We also spoke to, military and defense applications, folks from NASA, Boeing, Raytheon, and also stationary energy storage for grid enhancing technologies. And one thing we observed is that EV market is moving fast. EV companies are betting big on new technologies and new battery chemistries, as opposed to military and defense and also stationary energy storage, where they're looking for tried and tested solutions. Right. So yes, we can target these markets right now, but the reason why we are targeting them as we scale the company in a couple of years is because first we plan to try these products on EVs in partnerships with the battery makers. And once it's tried and tested, we can scale the product and apply commercial level technology for energy storage in the grid.
And you said semi-solid state. Can you describe, what's currently on the market? I know solid state promise has been coming forever, but isn't quite here yet. So what's the benefit or the challenge of semi-solid?
So the benefit of semi-solid is that we can not only use this battery technology in the conventional lithium-ion batteries that we have today, but this CAM technology can also be used in solid state batteries in the future, which is where semi-solid comes into the picture.
Cool. Awesome. 8 seconds. I think we're going to call it there, but thank you so much. All right. So as I see everyone dressed up all nice today, I do have a joke about how things look, I suppose. But what's the difference between a bicycle and a tricycle? A tire. Yeah.
I mean, I laugh.
I like
that.
All right, so that one's pretty good. All right, so our next team is Rise Reforming from University of Chicago. And so judges are getting faster with making some notes, figuring out our feedback form. And we'll bring up their slides and then we'll get going.
All right, guys, we have one more pitch.
Yeah, just one, then you guys get a break. No mics, all right.
Like it. All righty. So plastic bags, almost all of them will end up in the landfill or nature. Now, 5%, only 5% of plastic is recycled in the US today. And while we all know that plastic pollutes the environment, it turns out it actually pollutes the atmosphere quite a bit as well. Researchers have found recently that 40% of plastic decomposes into CO2 and CH4 within 25 years. At the same time, the chemical industry accounts for 5% of global greenhouse gas emissions. And the dimethyl ether industry in particular, DME, relies heavily on fossil fuels. I was going to bring a can of DME with me here today, but the TSA wasn't too pleased. So we have plastic waste and we have fossil-derived chemicals. What if we could kill those two birds with one stone? Enter Rise Reforming. We seek to turn the tide on the plastic disaster using a revolutionary path to carbon-negative chemicals. I'm George Rose.
I'm Lucas Tubilla.
And I'm Johan Van Oort. Three of us study molecular engineering at the University of Chicago, and we are advised by two chemical engineering experts and an aerosol industry veteran.
At Rise Reforming, we see plastic waste as a virtually unlimited resource. We envision a first-of-its-kind plastic dimethyl ether, three-stage catalytic process, and we aim to make carbon-negative dimethyl ether at a price competitive with fossil-derived dimethyl ether, all while erasing plastic waste.
So our primary target market is the LPG industry, commonly known as propane, and we aim to capture its domestic and transportation segments. Our CNDME and LPG can be blended to make a drop-in alternative fuel that reduces LPG's life cycle emissions by 35%. Our secondary market is the aerosols industry, where DME is an environmentally friendly propellant used in air fresheners, hairspray, spray paint, and insecticides. Overall, Rise's CNDME allows these two industries to continue to expand while meeting emissions targets. So our TAM is a fast-growing global DME market, which has a near future predicted CAGR of 10% and a value of $22 billion by 2035. Our SAM, as I just mentioned, represents DME and LPG blending and aerosols, and it's around half of our TAM. And our SOM goal is to achieve 1% market penetration by 2035 in this SAM and 10% by 2050. So we'll get our feedstock by collaborating with waste management companies to divert the plastic that are otherwise disposed of. We also aim to capture that 95% of plastic waste that doesn't get recycled by strategically placing our modules at materials recovery facilities. This eliminates the need to transport the plastic ourselves and also ensures a continuous flow of feedstock. Last year, Chicago waste management companies spent $40 million on plastic-associated landfill fees. This makes our diversion service attractive because we would be avoiding those fees for waste management. So why modular? Well, modularity gives our business model several key advantages over your average large-scale plant. First, rapid deployability. Our modules require a construction time of weeks rather than years. Second, lower CapEx costs and a quicker payback period. Third, greater reach. More units means more communities served. Fourth, scalability, as units can be stacked to meet demand. And lastly, lower risk, because if operations in one module fail, others can continue with production.
We consider our competition to be both legacy DME producers who still dominate the market, as well as renewable DME startups like Dimeta and Oberon Fuels. Whilst both Dimeta and Oberon produce near zero carbon or carbon negative DME, neither company can reform mixed plastic waste, and neither solution is modular. Legacy DME producers use natural gas to produce DME. Relying on plastic waste, on the other hand, makes our product carbon negative by avoiding methane emissions, and gives us an emission reductions potential of 2.9 kilograms of CO2 equivalent per kilogram of DME used. Rise's CNDME also competes price-wise with fossil-derived DME at $2.14 a kilogram, especially considering that aerosol-grade DME sells for around $2.60 a kilogram. Our modules are an attractive investment. The cost for a module predicts to be around $450,000, yielding an MPV of $1.5 million over the module's lifetime. This gives us a payback period of 4.9 years and an IRR of 26%. Potential customers within the LPG industry include major distributors like Ferrellgas, Gromark, and others. Customer discovery has indicated substantial interest in our product within the LPG industry. And additionally, LPG companies are taking major stakes in the DME economy, with Suburban Propane acquiring 40% of Oberon Fuels. On the aerosol side, we have acquired a letter of intent to purchase cylinder quantities of our CNDME should we successfully assemble a pilot module. Other aerosol executives like John Ferring have also expressed serious interest in our product. We will continue to use LOIs to secure customers in the future and hope to set up DME purchasing agreements where we agree to provide DME at a fixed price each year, similar to PPAs.
So funding obtained will first go to a lab scale demonstration at M-Hub in Chicago. The estimated cost of such a lab scale demonstration is $55,000. We also seek $20,000 to patent the full concept. After the lab scale demonstration, we will search for funding to scale up to a pilot module. So reaching our 2050 SOM goal would mean erasing 4.5% of 2021 US annual plastic waste and removing 6 million metric tons CO2 equivalent each year. That's equivalent to taking 1.3 million cars off the road every year. Additionally, our solution supports the aims of environmental justice as well, as plastic pollution disproportionately plagues disadvantaged communities. So the chief beneficiaries of our solution are really the municipalities that we serve. At Rise Reforming, we believe that today's waste has tomorrow's value. Thanks, and now for any questions.
All right, just about 2 minutes, so quick questions.
One of the differentiators versus the other startups, I don't think this is actually working, was that you can take multiple different plastic streams. So how big of an issue is that in today's market in terms of the waste streams from which is that really inhibiting the two other players today? Or?
Absolutely, yeah. So, I mean, taking mixed plastic waste is kind of a deal breaker, or in our case, it really makes our offering, because in other cases, you have to sort, right, which is another step in the process. One of the companies up there actually just doesn't deal with plastic really at all. They kind of deal mainly with organics, like cow manure, food waste, that type of thing. The other company has the capability to take certain plastics, but they have to separate it out. So our process enables, taking all of them at once, which eliminates that step of separation.
Okay.
So your IP is around the conversion process itself?
That's right. The whole IP is the conversion of plastic waste into dimethyl ether, and it's a 3-step process. So the first process has been around for a while. It's just gasification. And the last process is the only way you can make dimethyl ether. It's the conversion of syngas into DME. So really the novel part is that second step, and we are going to patent all 3 together. So we kind of combine the first and the third with that middle step. IP is the full thing.
So it sounds like you're a TRL3 right now?
That's correct.
Okay, and so to actually produce that module, how custom or off the shelf might that step be?
Yeah, so everything except for that middle step is off the shelf.
Oh.
That middle step will require, that's what we designed. That's our product, right? But yeah, everything else is off the shelf.
All right, that is the time we have for questions, and thank you so much. Before you leave, before everyone stands up, you guys can. Want to thank everyone for powering through. We will come back at 5 minutes after the hour, so 10:05. We gained a minute somehow. We are not behind. We're a minute ahead. If you've already presented, please do fill out that feedback form, either using the QR code or on the paper form. They'll be at the exits. Your feedback really does value. I do like it after you present because you're a little bit calmer, but before you found out if you want to watch, it's the right time to get your feedback. But otherwise, go find some coffee on the 3rd floor. Come back 10:05. All right, so we're going to return right on time and keep our process moving. So thank you, everyone. The right side of the room, my right side of the room, is looking much fuller than the left side. We'll bring people in from the hallway and we'll fill this back in. So our first team coming back is going to be Agrivoltaic Design Studio from Cornell University, if I remember my notes correctly. So welcome and come on up.
Okay. Have a nice break. I'm Henry, and we are Agrivoltaic Design Studio, the solution to one of the biggest challenges in the solar development industry right now. To get to the root of this challenge, we firstly have to understand that a lot of solar goes on farmland. So let's think like a farmer. Farmers struggle to maintain a stable income because farming is hard, and a lot of farmers are looking to alternative sources of revenue to complement their farming revenue. And a lot of farmers that we've talked to have piles of business cards from solar developers on their dining room tables. Solar developers want to lease land from farmers. So the farmer has a choice, farming or solar. If the farmer goes with solar, there's a number of challenges that come with that. For one, the farmer doesn't want to stop farming. They have their farming legacy that they want to keep. And there's also community pushback due to the loss of ag land from solar. All of this threatens the success of the solar development. And this is not a unique scenario. With 83% of solar destined for farmland in coming years, we're seeing a third of projects being canceled because of the pushback due to the loss of ag land. All of this amounts to a $5.7 billion industry-wide annual loss in sunk costs. And resistance to solar is only growing. Right now, the number of US counties that are adding solar is equivalent to the number of US counties that are blocking solar. Agrivoltaics is a potential solution to this, where you combine solar and agriculture on the same land. It's a win-win solution because the farmer can continue farming and the solar developer can do what they do best. But agrivoltaics as an industry is new and it creates a lot of complex challenges. For one, there's uncertainty about the compatibility of crops and solar. And then there's also a lot of risk associated with these new dual-use designs. That's where we come in. Agrivoltaic Design Studio makes agrivoltaics possible. Our solution for solar developers guides development engineers through the process to create an optimized agrivoltaic design, giving insights on energy output, agricultural yield, return on investment, and risk assessment for insurance. It's a peer-reviewed approach, and it was developed at our Cornell lab. We drive a new development approach for solar developers. Currently, developers go into communities, decide that they'll build a solar farm, and then announce and defend that decision. We allow developers to engage with community members, co-design with farmers, and finally decide on a mutually beneficial solution with agrivoltaics. So going back to our farmer's dilemma, now we can see when the developer uses Agrivoltaic Design Studio, the farmer can have both stable income from solar and continue the farming legacy. In doing so, we align stakeholder incentives from the community to the landowner and the developer. We sell software as a service. Our pricing model is based on the assumption that we can reduce cancellations by 40% and capture 20% of that value. Our subscription is $12,000 per user per year, which is in line with what development engineers pay for conventional design tools. Our revenue growth is predicted to grow as solar deployment goes on farmland. Agrivoltaics as a market is targeting this $5.7 billion annual sunk cost, and our customer base is under the assumption, again, that we can reduce project cancellations by 40%, capture 20% of that value. We have several potential early adopters who we've been co-developing this technology with, and we have 4 verbal commitments to use our technology in a pilot run. Compared to our competitors who offer consulting services, we offer software as a service. It's a standalone software that goes to the development engineer who makes the final say in the design, whereas our competitors target a project manager. Our approach is engineering focused, it's peer reviewed, and we include risk assessment for insurance, which is necessary to get agrivoltaic projects to completion. As we go to market, we'll leverage our industry network to get connections with the people who have purchasing power and the development engineering groups. We'll start with a pilot run this year in the Midwest and Northeast with our partners, and then we'll expand to the entire US. In 2026, we'll increase scope to racking manufacturers as well as civil engineers. We'll use this prize to launch our MVP and then iterate and train development engineers on how to use our product. We'll add features as we go, and our investment will be used for software developers as well as operational resources. We need some computational power, but most of our technology will be continued to be developed in our lab. Our team has been co-developing this product with developers and farmers over the last 3 years. We're currently negotiating an exclusive license through the technology licensing office at Cornell, who owns our IP. We've been featured prominently in the news, and we're working on several grants, including one from the Department of Energy to look at ecosystem services in solar farms. And we'll leverage this as we go to market. Overall, we unlock equitable solar energy deployment in the US with agrivoltaics, bringing solar to the center of a stable income for farmers, community benefits, and climate resilient agriculture. Agrivoltaic Design Studio makes agrivoltaics possible. Thank you.
Thank you so much. And 3 minutes to Q&A.
I think you said, I keep picking up this useless mic. I think you said that you were targeting software engineers instead of project developers, but a big part of your value proposition is that you're helping actually like engage the community and actually get like support for the project. And in my experience, a software engineer is not the most external, vocal community engager. So can you help me understand how that is going to work?
That's a great question. So what we're doing is bridging a problem that we see where the project manager is currently not really communicating with the development engineer as much as they need to. Our competitors will work with a project manager to come up with some romanticized agrivoltaic design. They'll spend several months on that, iterate, bring it to the development engineer. The engineer will say, sorry guys, because of the engineering constraints, we just can't build this. So we're bringing the product to the development engineer who can then bridge the gap with the project manager and the farmers.
Okay, the project manager is still doing the external community development kind of stuff.
Yes.
Okay, one more question. You mentioned that a big part of your revenue model, et cetera, is sort of predicated on reducing cancellation rate. It feels like maybe that's a short or medium term problem until people start to see that there are these, dual use kind of approaches. And so how does that affect you, how you price and how you kind of your business model going forward?
Yeah, that's a great question. So right now, like you said, the cancellations are what is motivating developers. But we're seeing in Europe right now, with the farmers having a little bit more lobbying power in Europe, that agrivoltaics can be really successful and can bring more project profitability to these projects. So that's what we see as the future in the US. But right now, like you mentioned, the developers are more motivated by this project cancellation.
Okay, so you imagine your business model kind of evolving in terms of how you price.
Yeah.
Okay. Thanks.
Can you talk about how IP is protected for a SaaS?
Yeah, so we have a copyright, and we're negotiating a license, or we're negotiating licensing our IP from Cornell because Cornell owns it. And so it's just a copyright.
And you're protecting.
We're protecting our soft, like our algorithm basically.
The algorithm,
yeah,
okay.
Exactly.
Can you talk about why farmers would want to go this route instead of just wind developers?
Right, wind is also a great opportunity. Wind presents a number of risks. It's unlikely that this will happen, but turbine blades can, spin off and create a lot of, havoc that is not ideal. Also, wind requires access roads to each turbine, and so that's challenging for farmers as well. But in the Northeast, at least in New York, what we're seeing is a lot of solar is going on farmland. Wind you can see for miles away, but the aesthetics of solar only disrupts the natural landscape as you get closer to it. So it's a little bit more, the rural communities are a little bit more supportive of solar just because of that.
Awesome. That's 8 minutes. Thank you so much.
Thank you.
I'm gonna leave this microphone turned on for you guys.
Thank you.
And find my notes. All right, so I have a slightly longer joke while they make some notes. But so as a dad joke, my son was asking me if I could answer a question of his about the eclipse. And I was a little busy, I was a little distracted. He said, hey dad, can you tell me what is the solar eclipse? And I said, no son. And he's like, why not? And I said, I'm busy. And I said, no son. And then he went and asked his mom. I'm done. All right, so our next team is Catherine Callis and Madison Freeman from Stanford University for EarthFlow AI. I still see judges rapidly writing. All right, someone looked up. All right, we can go.
So, hello, we're EarthFlow AI, and we're unlocking climate opportunities in the subsurface using AI-based physics simulation. To reach our net zero goals, we will need to tap into the energy opportunities that's in the subsurface. We'll need to scale up our carbon capture and storage capacity by 200 times, our geothermal energy by 26 times, and our lithium brine extraction by 25 times. But all of these resources lay in the underground, and in order to unlock them, we need to model what happens when we inject or extract fluids from the subsurface, which is called reservoir simulation. Let's take the example of carbon storage. Currently, developers are limited to a single simulation run for a project because it's very expensive. It takes a very long time for these simulations to run, and there's limited personnel who can do this. But in reality, we should be running thousands of simulation runs to get a probabilistic understanding of what will happen when we inject CO2 underground. We want to make sure there's no brine or CO2 leakage from the site or any induced seismicity, which could harm nearby local communities. Therefore, there is a need for faster and cheaper simulation, and that's the problem that we've been tasked to solve.
Through the past 5 years of PhD research, we've developed an AI-based physics simulation tool that is just as accurate as existing solutions, but 700,000 times faster, and it's easier to use. You don't need to be an expert reservoir engineer to use this. We've applied it to the first domain space of carbon storage, and it's showcased on our web application, ccsnet.ai. You can easily see on our web app how a reservoir parameter such as thickness will impact your CO2 plume and your pressure buildup. Now you can run the thousands of simulations needed to develop safer projects in just seconds. We do this through machine learning. So we have the same inputs and the same outputs as traditional numerical simulation, but the step in the middle is different, and that's where we're saving on time and cost. Traditional numerical simulation takes hours or days to run. Our solution takes a large data set of numerical simulations and applies model weights, and the result is that we get outputs in seconds. And this can be applied to any subsurface flow problem, including lithium brine extraction, geothermal, and hydrogen storage. Currently, as first movers in the space, we don't have any competitors, but we believe potential competitors will come from the traditional numerical simulation companies listed on the slide. However, they've been primarily focused on oil and gas development and have left an unmet market need for faster, highly accurate, and cheaper simulation that focuses on the energy transition, and that's where we believe our differentiating factor will lie.
Awesome. Thanks, Catherine. So we have been focused on carbon sequestration because of a number of policy elements, including the IRA, that have galvanized the carbon capture and sequestration market. So over the last 6 months, an interdisciplinary team of us students have been focused on exploring the business model case to bring this academic solution to market. We've had hundreds of active users on the website that Catherine showed a few slides back. And we've also interviewed more than 100 people, including potential customers, stakeholders, and regulators. We've had really strong initial positive feedback from developers who've been very interested in using the platform because of all of the factors that Catherine mentioned, the ease of use, the speed, the ability for multiple folks on the team to have visibility into these projects. And we've also progressed to pilot stage agreements with some of these customers. We've identified who our ideal customer will be in the initial phase and who the buyers and users of those companies will be. We've explored a couple of different business model potentials, both through these customer conversations, as well as talking to startups that have leveraged machine learning and other parallel clean energy spaces. And we've settled on a path to scale that includes starting with engineering consulting projects so that we can learn a tremendous amount from our early pilots, and then shifting eventually to a simulation as a service platform in which we're able to service and work with a range of customers and stakeholders across the ecosystem. So one of the reasons that this is really important is because simulation and modeling costs are a huge part of project costs in the subsurface. So our typical initial customers that we've surveyed are spending on average around $1.5 or higher million per project on just simulation costs. This goes upwards with the scale and complexity of projects, and we've seen projects that have spent $4 to $10 million per project just on the simulation costs and reservoir engineering time. And so we've, through a series of analyses, we've settled on a figure of about $350,000 per project. That allows us to seriously undercut any of the other companies on the market, and also allows us to build to about $100 million in revenue by 2030, with gross profit margins of 80% or above. We think that a range of stakeholders will benefit from this solution. As Catherine mentioned, using EarthFlow allows all sorts of folks to be able to access projects and understand what the project impacts will be. And so this allows project developers to build faster, cheaper. It also allows regulators to be able to evaluate projects and run a tremendous amount of different scenarios to look at safety. It empowers local communities to be able to feel confirmed in the safety of projects in their backyard, and allows investors and insurers to better diligence and underwrite projects. And so we have seen the range of solutions and resources in the subsurface that we think will galvanize the clean energy transition. And we're hopeful that EarthFlow AI will help to unlock a much broader range of development in the space.
Awesome. Thanks so much.
I'm just gonna speak.
Actually try to use it. When you guys are facing this way, people at the back don't.
Okay. Great job. was thinking something, when developers are trying to market these projects to financiers, they have to validate all their financial assumptions and technical assumptions. And financiers tend to not like things that are kind of new. And because your algorithm is kind of new and it hasn't really been used in industry much, what are your thoughts about overcoming that hesitancy for the investment community to trust that your technology is valid?
Yeah, that's a great question. So we are verifying our tool through a $25 million pilot project in Australia right now. And we're competing with other people using the traditional numerical simulation tools, a variety of different ones, along with our tool. So we'll be able to have evidence that our tool does just as well, if not better, hopefully, than the other simulation tools. And that should hopefully alleviate any concerns on accuracy or any other verification concerns that people may have.
I'd also say that financiers, and like we've spoken to a number of investors in the space, they're not doing the analysis themselves. They're working with independent engineers that they generally contract, to do a lot of different work and evaluate different projects. And those engineers have been really interested in this solution because it allows them to do, have the exact same output to their customers, analyze things the exact same way, but do it much faster and have it be much easier touch and more legible to the folks who are actually looking to get an answer on the project itself. So we haven't run into any headwinds there.
I'd love to hear more about the database of, prior projects that you have in order to facilitate this. Like, what are the inputs in, and where is that proprietary? And so how's that like driving the machine learning capabilities?
Real quick.
Oh.
Yeah, so we've generated a synthetic data set that's based off real geology and real projects in the past. Our lab has participated in many of the carbon sequestration projects that have been in the past few years. Happy to answer this question more, but we'll have a data flywheel as well as we develop more projects. Right. We'll be incorporating their project data into our training data set to hopefully build that out.
Thank you.
Thank you.
All right, so why were people so nice to the AI? Because it was really self-conscious. Maybe. And so someone asked whether or not my job got easier by using AI to come up with these jokes. And I'll give you an example of one of the answers I got when I asked about a prior presentation. Why did the energy efficient squirrel become a hero at the paper mill? Because it sealed all the air leaks and turned the place into a sustainable breeze. Don't know what they were going for.
You won't get replaced.
Also, why did the solar panel blush? Because it saw the light. My jokes are corny, but I think they're slightly better. I'm also not coming up with them. I'm finding them from other people. But with that in mind, humor is maybe not yet solved. All right, our next team is Echo Solutions from University of Houston. Welcome.
Hi everyone, my name is Prince, and I'm excited to share with all of you today our business, Echo Solutions, which aims to help accelerate the energy transition as well as help mitigate the effects of climate change. Now, our technology produces green hydrogen and simultaneously reduces the carbon dioxide from the atmosphere. Now, our technology leverages on the ocean's natural capability to capture CO2. How it works is that our system intakes seawater, splits the water molecule, producing hydrogen gas and high alkaline seawater. Now, by discharging or returning this high alkalinity seawater back into the ocean, we are effectively increasing the ocean's capacity to absorb more CO2. And also in doing so, in using this approach, we are eliminating the need for CO2 compression, transportation, and sequestration infrastructure, thereby further reducing our costs. Another thing that's special about technology is that it is entirely electricity driven, which can be from renewable sources. It also eliminates the need for expensive and fouling prone membranes, and also expensive and rare metal electrodes such as platinum, which is used in conventional systems. Now, the McKinsey & Company reported that the demand for hydrogen in the next couple of decades is going to increase, particularly in the mobility sector. Road transport, the aviation, and the marine industries are going to experience the most significant increase in this demand. The CO2 price is also, the value, I would say, of CO2 is also steadily increasing, significantly more so in Europe, which is primarily driven by their aggressive implementation of CO2 mitigation policies. The United States is also steadily catching up, with California leading the way. In recent years, more and more companies are voluntarily implementing or incorporating the cost of emitting CO2 into their internal decision-making process, which we believe is going to further drive the value of CO2 up in the future. Now, our business will focus on coastal industries that have existing seawater intake infrastructure, like LNG terminals, desalination plants, coastal power generation facilities, co-locating with these facilities as well, taking advantage of their existing seawater pumping infrastructure will further reduce our costs. The hydrogen that we generate will be a revenue source for us. We believe that the demand for hydrogen, especially in the Texas Gulf Coast, maybe Louisiana as well, will increase in the next few years. The Department of Energy has recently announced a $7 billion initiative to fund 7 hydrogen hubs all across the United States, and Houston is said to be the largest one, which happens to be where our company is located. Although there are already a few companies, startup companies that are servicing the green hydrogen and marine carbon capture market, we believe that these markets are still very nascent, and thus the demand for green hydrogen and marine carbon capture removal services are still high. We envision our minimum viable product to be contained in these 40-feet containers with a base capacity of 8.6 million gallons of seawater per day, which can be scaled up depending on the site. And to put that into perspective, a typical LNG import terminal handles about 96 million gallons per day. At that scale, we predict to produce about 12 tons of hydrogen gas per year and 1 kilotons of CO2 per year. Now, in the early stages of our business, we will offer carbon capture as a service to these coastal industries, charging them per ton of carbon that we capture for them. Our clients will benefit from the 45Q tax credit, where they can claim up to $180 per ton of captured carbon. In the later stage of our business, we plan to partner with engineering, procurement, and construction companies, where they can offer to install our tailor-made units into their site, specific to their site and their sustainability goals and needs. Based on our techno-economical analysis, we determined that our capital cost is about $15 per ton of CO2 captured, and the operational cost at $75 per ton of CO2 captured. We were able to significantly reduce our capital costs because of the novelty of our system design. With the offset of the hydrogen sale, we are able to bring down our break-even cost about $40 per ton of carbon. And in some CO2 offset markets, the value of the CO2 can actually go as high as $1,000 per ton. And we believe the reason for this is that many businesses are motivated to offset their carbon, not just to benefit from the tax credit, but also to increase their ESG score ratings, which gives them indirect benefits such as insurance discounts and other government incentives. Now, at this point in time, we have successfully confirmed the feasibility of our membrane-less system, and we are now in the process of optimizing our operation parameters, which will inform our design and construction of our pilot plant by the end of this year, hopefully. And the beginning of next year, we plan to partner with a coastal facility to integrate our system into their design or into their site and test our system further.
All right, so that's our 6 minutes, and we have just under 2 minutes for Q&A.
And I'd like to invite my colleague, I'm going to answer the question.
Great job. So you said you're membrane-less. Can you say more about what is happening in this process? Is it a solvent? Like, what's going on in there?
Well, the electrolyte is going to be seawater. But we were able to manipulate our cell design so that we eliminate the need for membranes. I don't know how much I can share because technology we're developing is very new. But basically, it has to do with the design of the cell, the flow design of the cell that we were able to eliminate, and as well as the features of the electrode itself.
Okay, so it's chemistry plus the design of
electrochemistry. Yes. Yes.
Does it have any of those rare earth kind of materials that fuel cells do as well?
One of our goals is to explore more abundant and cheaper electrode materials to avoid we recently published a perspective paper on the current proposed designs for electrochemical direct ocean capture technologies, and a lot of them use platinum. And we've actually did a sort of initial calculation where if we were to scale all of the proposed designs so far that have been proposed so far, I think one of them we would require 600% of the global platinum supply. If we were to create a 1 metric ton CO2 per year capacity plant. So yeah, we were motivated by that to design a system that will utilize very cheap and very abundant electrode materials.
Thank you very much.
Thank you.
All right, thank you so much. So what did the ocean say to the shore? Nothing, it just waved. Yeah, he's got it. Daniel's got it. All right, this next one, 2 hydrogen atoms having a cup of coffee. One looks to the other and says, "You look worried." "I am, I've lost an electron." "Are you sure?" "I'm positive." All right, our next team is Molten Salt Consulting from Snow College. So a couple notes happening, but we can, what did the bottled water tell the spy? The name is Bond, hydrogen bond. All right, we found some microphones and
thank you.
Welcome.
Hello, I'm Shane Scougard. This is Maggie Wu and Ashley Littlefield, and we are part of an undergraduate team from Snow College. Our team has developed a business plan for a company that would consult other organizations developing molten salt nuclear reactors.
There has been an increase in energy demand across America and the world. There are many current energy generation technologies, but they always seem to fall short of the demand. These modern energy generation technologies have many disadvantages. Some of them include harmful gas emissions, pollution, and dependence on weather.
Many of these hindrances can be addressed by nuclear power generation, but there are currently only 400 active nuclear reactors, and 300 of which are light water reactors. But light water reactors come with their own faults, including in difficulties in load following, restrictions on location, and enduring negative public perception.
So the molten salt reactor addresses these problems. The proposed designs claim huge advantages in safety, small size, and efficiency, potentially lowering the cost of electricity to 2.5 cents per kilowatt hour, which is much significantly lower than any other major energy generation methods. Unfortunately, this technology is held back by a lack of thermophysical data on the molten salt materials being proposed in these designs. This data is required for Nuclear Regulatory Commission approval prior to commercialization.
Many of the molten salt reactor development companies are still using physical experimentation. Physical experimentation is extraordinarily expensive and difficult to do. In a recent conversation with Alpha Tech Research Corps, a molten salt reactor research company, they found the coefficient of thermal expansion for the molten salt mixture slide. It took them 1.5 years and $300,000 to obtain this single parameter. We have a new option.
In recent decades, research has revealed the possibility of simulating molten salt mixtures for which there is already experimental data through ab initio molecular dynamic models. However, these supercomputer simulations require already experimentally obtained values to be used as a set of guide to set the appropriate tuning parameters. And in the last year, we have developed a But in the last year, we have crafted and applied a standardized procedure for executing similar supercomputer simulations, enabling the procurement of data on salts that have yet to be extensively studied experimentally.
This graph on the right shows an example of some of the data we've been able to collect. From the data of these unexperimentally studied salts, we can get the heat capacity, and that is 1 out of the 12 parameters that we need.
That's right. Our action plan includes 2 phases. First, it will be important for us to guarantee the security of these molten salt compositions, the proprietary mixtures that these companies have, as well as their correlated data. To obtain this credibility, we would need to receive the NQA1 certification, the Nuclear Quality Assurance certification from the American Society of Mechanical Engineers. This certification will provide an additional assurance to our potential customers of the dependability of this new novel method. We will then contact our initial target companies, including these 4 organizations who are using proprietary molten salts for which there is little to no experimental data as of yet. Still in phase 1, we will use our high profits to develop machine learning models, which will speed up our process, as well as allow us to determine additional different thermophysical properties. We will then expand our supercomputer resources, the computational resources in phase 2, and continue expanding our customer base to include all molten salt reactor companies.
So we calculated our total cost for finding 1 property of the molten salt would be $23,400. That is including our computational and overhead costs. We would charge $50,000 per molten salt property. With our current personnel, that would give us a $26,600 profit per molten salt property.
Many of these companies are ready to build a prototype and start getting NRC approval as soon as they have their all the thermodynamic properties for their salt mixtures. This puts us in a position to significantly impact the speed at which this technology comes to market. With our novel computational methods, we can decrease the time needed to measure properties from years to weeks, and we can decrease the total cost for these companies from millions to thousands. This will free up time and money for prototype and reactor development.
That's right. Our potential impact is not just substantial, but enormous. It would provide a revolutionary path forward for molten salt reactor technology, and thereby, in turn, provide the world with low-cost nuclear energy.
Awesome. Thanks so much. We have just under 2 minutes for question and answers.
So can you help me understand how big the market size is? I don't know a lot about molten salt and how many companies there will be, but it feels like you're doing a one-time project for each new initiative that might happen. And then it's proprietary and can't be reused. And so I'm trying to think about the scale, how many of these you could actually do, how big the business could be. It seems like it's just one-offs periodically for new entities that have a new chemistry.
Wonderful question. So there's already over 40 molten salt reactor companies here in the US, and we expect to continue to grow as this technology develops. But as we said, there's over 12 properties per molten salt that need to be analyzed, but each of those salts also need to be analyzed with certain contaminants, all at certain concentrations. So there's really a mountain of data that these companies need in order to receive this NRC approval. And it's really what's keeping back this technology from developing and entering the marketplace. Otherwise, it would be already, these technologies are ready. They just need NRC approval and they need this data. And it's huge, it's a lot. So it's not like we're only going to be working with the company for a year. They're going to need continuous data for years and years as they continue to grow.
So just to clarify, it's a data subscription model where they're getting like ongoing properties, or are they one time getting the property and checking a box?
So it'll depend on the certain company. Many are using multiple different molten salt mixtures, but there's different stages to the NRC approval pathway. And so the first, they'll just want their basic mixture and those properties, but continuing on in the years, they'll want the contaminants and other concentrations.
Awesome. Thank you so much.
Thank
Great
you.
job. And I'm going to try this joke that I don't know exactly how to deliver it, but something about saying nah to salt in my water. But then I remembered my periodic table. I thought, no, that's so dumb. Sodium, so dumb.
Yikes.
Maybe?
Wow.
Yeah,
Wow.
that was a little bit tough. So I see some notes still happening. Danny's resetting our timer and pulling up our next team. Looks like someone's ready and waiting in the wings. So we will go with Oxylus Energy from Yale University, focused on carbon conversion to carbon neutral fuels. Come on up. Welcome. Thank you. And one more. There we go.
Well, thank you, everyone.
Hi, Gordon.
Everyone
Grab a chair.
So, my name's Harrison. I'm Connor, and we're Oxylus Energy. We're a Yale climate tech spinout, and we convert CO2 into carbon neutral fuels. As we all know, climate change is a huge problem, and there are many sectors that can be decarbonized via electrification, but there are some hard to abate sectors like shipping, aviation, and petrochemicals that require alternative fuels. Yet there's a profound supply-demand mismatch because current alternative fuels are costly, they're hard to scale, and some of them, like ammonia and hydrogen, are toxic. And so this is why we focus on methanol. It's an energy-dense liquid hydrocarbon at room temperature and pressure that can decarbonize industry. It's used as a drop-in fuel replacement for shipping, can be upgraded to sustainable aviation fuel, and be used in high-valuable petrochemicals. And this is a huge market opportunity. But most importantly, it's 11% of emissions today.
So the problem is making these alternative fuels or alternative methanol. So the way to do this is there are three inputs. We need captured CO2, for example, from a point source. We need renewable electricity, and we need water. Combining those inputs, we need a very efficient process because we're fighting thermodynamics here. So we need to make methanol efficiently with low capex and high energy efficiency. And that's what we've developed. So during my PhD, I've been working on this electrochemical CO2 reduction to methanol. We've developed the only catalyst that exists today for direct CO2 to methanol in an electrolyzer. So these electrolyzers look very similar to a water splitting electrolyzer. The hardware is the same. There's three key components. There's a anode, membrane, and cathode. Our key innovation is in the cathode. So we have a catalyst there that can convert the CO2 into methanol. This is really important because the way to produce methanol today from CO2 is in multiple steps. That's high capex and low energy efficiency. So first you need to make green hydrogen, you need to compress it, react with CO2 at high temperature and pressure to make methanol. So this is low energy efficiency, high capex. We combine all these steps into one, producing liquid methanol at room temperature and pressure.
This allows superior unit economics for green methanol. We have the highest selectivity, the highest energy efficiency, and this enables the most scale for carbon conversion to methanol, allowing us to reach the fossil cost of methanol at around 51 to 53 cents per liter, allowing us to decarbonize industry. With the lowest emissions and cost of production, this is done by energy efficiency, no hydrogen input, room temperature and pressure, and dynamic load compatibility.
So we've been busy in the lab demonstrating the scalability of this technology. So from the first catalyst discovery in the bottom left of that plot in an H cell We've been putting this catalyst into commercially viable electrolyzers, membrane electrode assemblies, they're called, showing from 1 centimeter squared active area to 50, and actually recently manufactured 100 centimeter squared size, can make about a coffee mug of methanol in a day. So now we need to scale this to a pilot. It's about 10 times the size with a stack of those.
And so we see electrolyzer stack production from the commercial to industrial scale in 3 phases. First is that pilot electrolyzer production, then commercial deployment around 50,000 liters per day, and then industrial deployment at around 150,000 liters per day by 2028. And you can think of this as containerized carbon conversion factories. Within one container, we take CO2, separate any impurities, convert it into methanol using our electrolyzer stacks, and distill that methanol out. And this can be used with integrating infrastructure, where we put this carbon containerized factory wherever there's a CO2 liability and offship that methanol that can use traditional and oil and gas infrastructure.
So our differentiated technology has distinct advantages over the competitors in the e-methanol space. So those competitors use that multi-step process that relies on high heat and pressure. Therefore, it's not very modular, it's hard to electrify, has low energy efficiency. So our process is dynamic, higher efficiency. And we have the team really to bring this to market. I've been working on this technology for the last 5 years, just finished my PhD. Harrison has a background in chemistry, also in carbon capture and sequestration. Perry, our third co-founder, has a background in renewable energy development and is an engineer by training. So together we have the energy, CO2, and technology backgrounds to scale this. And then, of course, we've surrounded ourselves with plenty of people with lots of experience that can actually build this. Some of my lab mates that are hopefully our first employees, as well as advisors from industry and academia that understand the market and the technology.
And we've had bootstrap commercial and technical progress in just the last year. We've raised over 100,000 in dilutive and non-dilutive funding, have participated in a few pitch events like this great one here, and are now recently part of Third Derivative, one of the top climate tech accelerators out there. And so we thank you for your time, and we hope to build this together where we can create a circular economy for carbon dioxide.
Thanks so much. And just about 3 minutes for Q&A.
How pure does your CO2 input need to be?
Yeah, great question. So, it's something we've been investigating in the lab. Really, the impurity that cause problems is heavy metals. These will plate onto the electrode. So we've priced into our TEA, scrubbing that CO2, getting it to 99% purity to feed into our reactors. Ideally, we'll be able to get that down as we improve sort of the durability of the system.
It's less than 5% of our overall cost, even at a steel facility at around $90 a ton. So we're not too concerned about CO2 purity and scrubbing of impurities.
I feel like you did a great job helping us understand the technology and where you're at, and I feel really like you got deep there. I don't feel like I have a real good understanding of the customers and the business model, and I'd love to hear a little bit about your customer discovery thus far, like for your beachhead market, and like what the pain is you're solving for them, et cetera.
Yeah, so we've done over 45 interviews within customer segments in shipping, aviation, and petrochemicals, and we see there's a high willingness to pay for those early adopters and high valuable petrochemicals that look at e-methanol for creating polypropylene or polystyrene. Right now, for example, Lego has basically sourced all their renewable plastic via e-methanol because it's really easy to upgrade into polypropylene and polystyrene. So that's what we're going to focus on first, because consumer segments have a much more higher willingness to pay, and then go down the value chain as we scale up into aviation for sustainable aviation fuel and maritime.
And I don't think I heard the differentiated value proposition for choosing your solution though. Why does Lego want to use your solution versus other e-methanol providers?
I think it's because it comes down to cost and scalability. Like when you're looking at e-methanol, whether you're doing it that multiple step or one step like us, energy efficiency basically drives between 50 and 60% of cost. And so if we have energy efficiency of 50% versus everyone else has 14%, we're going to be, and already are, the most cost-effective way to do this.
Thanks.
30 seconds.
I'm curious how you might drop in to existing facilities, or would you develop your own infrastructure?
Yeah, great question. I mean, for the technology, really we're trying to use as much developed technology from hydrogen electrolyzers as we can. the anode membrane. We can integrate from proton exchange membrane electrolyzers, for example, and then really differentiate at or cathode where our IP is.
But at the plant,
and then at the plant scale, we want on-site decarbonization that really decreases the cost. There's no CO2 transportation there. And then methanol is a liquid, so the cost of transportation is actually very low. So we want to integrate into, for example, here at the Gulf Coast, using near ports where this methanol can be a drop-in for maritime.
Thank you so much. All right, so how does carbon dioxide make soda so bubbly? By obeying the laws of physics. I have to have some CO2 jokes, I suppose. So we are powering through and really enjoy everyone presenting. Hopefully you're learning a lot as well about the other technologies, the other potential, the other approaches to pitching, and seeing how everyone's approaching this competition. So thank you all for being here and sharing all of your thoughts and commitments. Our next team is Redefining Renewable Fuel. So next to present is John Shin and Abhi Chuda from UPenn and UMichigan. Welcome.
Thank you. Just like some slides that we just copied over, so in case it would be easier to read. If you'd like, there's more copies of it.
And I will give you.
Thank you.
That.
Thank you.
Thank you guys for joining us today to help redefine renewable fuel. Today, John and I will take you through our technology, which is a cost-effective biodiesel generator. First, we want to break down the problem. So currently, generation of power in the United States primarily comes from fossil fuels. Unfortunately, this causes an additional 250,000 deaths every single year. But if we're net zero by 2050, 7.2 million lives can be saved. Let's dive deeper into diesel production in the United States, which unfortunately isn't sustainable at all. It causes an additional 8,800 deaths every single year, 3,700 heart attacks, and over $1 trillion in damage to health every year. So what's the solution? It's biodiesel. Biodiesel can be used with existing fossil fuel infrastructure, serving as the bridge between the status quo and the net zero future. And the Department of Energy's Argonne National Lab and the Office of Technology Transition show us that biodiesel has 74% less emissions than regular diesel and is just as efficient. Now let's move on to our technology.
So our product is modular scalable algal photobioreactors that are connected with automatic harvesting and recycling units. And the entire system is a closed loop, meaning that it will conserve about 95% of the water and nutrients that go into it in terms of, in harvesting and algal growth. So we differentiate ourselves from the market standard in 4 main ways. One is cutting costs with the injection molding of HDPE pellets. The second is modularity, which decreases risks and increases precision. The third is the implementation of dozens of extra growth units into each system, which increases reliability. And the fourth, and perhaps most important, is the subsidization of our biodiesel prices with byproducts.
Now to move on to our theses, our first is our strong customer pipeline. Companies like Shell, Chevron, Boeing, and Honda all express initiatives to continue using biodiesel and have public statements and operations to do so. But we want to validate our business model. So we reached out to industry professionals, 2 of which are Sam Ramirez and Nathan Fink, whose credentials are above, working with companies like Honda and Shell, and they validated the want, need, and future potential of our biodiesel through our letters of intent. And at the same time, just recently, we talked to Michael Gilland, who worked with Chevron in the past in California, to refurbish their technology to be able to use biodiesel. He also told us that Chevron acquired the Renewable Energy Group because they could produce biodiesel at $6.70 a gallon. So then we asked him, if we can produce it for cheaper, will Chevron consider us as a supplier? He said yes. Now to move on to our market.
So we can actually produce these biofuels like biodiesel and biojet fuel for these companies that Abhi previously mentioned. We can also provide green electricity for households.
So our market is reaching over $200 billion in about 5 years, but we want to break this down a little bit. So our total market's around $200 billion. Our serviceable addressable market is around $17 billion, which is the algae biofuel subsector. And finally, if we capture 2% of that market, it's an obtainable opportunity of $340 million, primarily driven from demand by the increasing cost of fossil fuels and also legislation like the Inflation Reduction Act or Diesel Emissions Reduction Act. Now to move on to our competitors.
So breaking down our competitors, Algenol uses photobioreactors done in a different way that we do. LanzaTech uses CO2 sequestration, and Sapphire uses raised weight ponds. So one of the key things that we want to emphasize here is our focus on sustainability, because we use about 4 gallons of water per gallon of biodiesel produced, while Sapphire can use up to 60, and regular diesel production can use 7.
So now we want to kind of talk about the cost and commercialization.
That's our annual chemical costs, and that's also on your one pager. So one of the things that you can note is that you can actually reduce quite substantially these costs by utilizing papaya waste. A study by the USDA found that for every 160 kilograms of papaya waste that was used, you would be able to produce 1 gallon of biodiesel.
And it's not just limited to papaya waste, it's food waste in general. Wanting to show you the overall scope and potential of this technology. So let's talk about these byproducts.
So the most efficient way to make these biodiesels profitable is through the use of byproducts. So for every 2.1 kilograms of biodiesel that we produce, we can also produce 1 kilogram of dry lipids, which we can then sell for the market price of about $1. This means for every gallon of biodiesel, which is 3.34 kilograms, we can reduce this price by about $1.00.
Now to move on to our commercialization.
So as you can see, we're kind of like in the middle phase right there, the pilot demonstration phase. We have about 80% of the hardware done, and we need about $20K for the chemical costs, which are about $6,000, because we plan to run the system for months on end. We plan to do a lot of tests of reliability on it, and we need the warehouse space, which will cost about $14K, because my dorm room is no longer large enough to run this demonstration. We're going to use $50K then to develop the new injection molding manufacturing system, the upgraded multi-filter byproduct harvesting system, and the byproduct processing system.
What's important to consider here is that tax credits aren't factored in. Section 40A of the IRC tells us that there's a pure biodiesel production tax credit, decreasing our costs by $1 because we're a pure biodiesel producer. And by 2025, there's a Clean Fuel Production Act, which is, again, is a 25-cent decrease. So our actual levelized price by 2027 is $3.25, much less than the industry average. So finally, to address some risks.
So most of the risks you see here can actually be mitigated through just increased research and development or just by better quality control. One thing that we will have a harder time addressing is consumer confidence, which we actually can do by getting more government grants and getting more research institutions to back our technology. Fun fact, solar panels started out this way too. They were used first by NASA before becoming a household technology.
So we just need someone to give us a chance. At the end of the day, we're 2 people that just powered this by ourselves, and money we earned from working, with the mission of making clean fuel more sustainable and accessible. Please join us in making biodiesel and renewable fuel more accessible, attainable, and redefining it for the future. Thank you.
Thank you.
Great job, guys. Just one thing that popped into my head is your competitors are producing algae biodiesel, algae-based biodiesel.
Yes.
Why wouldn't your competitors just be any drop-in biodiesel?
We definitely can do that as well, but we decided to just use these as our levelized comparison costs. And for example, general biodiesel producer would be what Chevron acquired, the renewable energy group, and their cost was $6.70. So we just kind of wanted to provide a bigger scope and talk about like the market that we're competing with too.
Got it. But there is no difference between, right? Any customer that wants to buy biodiesel doesn't care, right? As far as you know.
Well, the thing with you growing algae, as well as John mentioned, you could use a lot of food waste to grow it as a carbon source, and it just is a very effective feedstock.
Yeah. There are other companies that grow not biodiesel, but other biofuels as well. One example is Honda. They also use photobioreactors, but they're not as scalable. So we just chose those.
So your differentiation is around the scalability of your process, and it sounds like maybe the filters?
Good catch. So our main differentiation is that most of these other competitors use autotrophic growth systems, which mean that they use very simple molecules and carbon dioxide, almost always pure CO2, to grow their algae. We use heterotrophic and mixotrophic growth, which is the combination of light and other large organic carbon sources like glucose and glycerol, things that we could potentially eat to grow. We're taking this more as we're thinking about algae as more like a crop, like corn or apples or something like that, rather than just an energy source.
This allows us to have biodiesel generators that are a lot more scalable, resistant, and aren't as fragile compared to the rest of the industry. Thank you for that question.
Because, sorry, one last distinction. In an autotrophic photobioreactor, they have to be made very thinly so that light can penetrate fully through. Ours don't need that, which is why they can be built much sturdier and don't have to be enclosed in the building.
Thank you.
Thank you so much.
Awesome, thank you very much. All right, so I did have a dad joke about oil, but it was too crude. Yeah, there we go. So we continue to move through our schedule, and you're all still here and eyes are still open. This is very exciting, very good. So our next team is going to be Electrolysis, accelerating the adoption of flow batteries from Georgia Institute of Technology, but we'll wait a moment. We're gonna take a moment of silence, maybe close our eyes for 20 seconds, not the judges. Just breathe. This has been a very full morning. The fact that we're going through 20 teams in the morning is a lot, so 20 seconds. Seconds is a long time. I probably still cut it short. Silence is awkward. Is that true? I think silence is awkward. But the judges look ready. So Georgia Tech for Electrolysis, accelerating the adoption of flow batteries. Welcome.
Hello, we're Pranav and Harry, and we're presenting Electrolysis, accelerating the energy storage transition to flow batteries. Currently, data centers are growing in popularity. Global spending on data centers is projected to grow to $49 billion by 2030. And inside of each one of those data centers are thousands of uninterruptible power supplies, or UPSs, that provide continuous power to all of the functions inside of that data center. This $12 billion uninterruptible power supply market has yet to modernize. They currently use lithium-ion and lead-acid battery technologies. And these have high capital expenditures and have a propensity to catch on fire and fail. To fix this, we propose using vanadium redox flow batteries, a system that has much lower capital expenditures due to the ease of scaling and due to its highly reversible chemical reaction. It can use 100% depth of discharge and has a high cycle life of over 20,000. In addition, these batteries are non-flammable and don't pose a safety risk.
In order to harness the power of vanadium redox flow batteries, we had to rethink what a UPS system can look like. Our system is a safe, modular battery backup solution which provides power to these data centers. In these two tanks are vanadium-based electrolytes, which get pumped into this power unit where the chemical reaction happens and power is produced. While we have rethought what a UPS system can look like, it is still a drop-in switch out for the lithium-ion solutions, which means there's no infrastructure change to data centers as we follow the standardized specification. Now, the current model is direct to consumer. So these UPS systems have to be repurchased every 3 to 5 years as these batteries have a fairly low lifespan. This presents a very high and recurring capital expenditure to the customer. Our solution is to sell backup energy storage subscriptions as an alternative to the $12 billion UPS market. Now, for this, the customer is provided with installation of our systems as well as maintenance, which is removing the capital expenditure to the customer. Now, a small to mid-sized data center is going to need 500 kilowatt hours of UPS storage space, basically. So by basically repackaging this system to do a full rack size, we are removing the packaging inefficiencies which comes with these very small systems, and which then enables us to achieve a very low total system cost. Now, looking to some future pricing, this green line represents the cost we would need to charge to install these systems and maintain them. Now, this orange line is the repeating 4-year purchasing cycle, which is standard for lithium-ion and lead-acid solutions. Now, as you can see, there's a window of pricing flexibility as we can gain a better understanding of the customer's demand and expectations.
Our unique technology and business model allows us to have some key strategic advantages. First, our system is simply cheaper than the industry standard. And this, coupled with its modularity, meaning we can take existing systems and resend them to other customers, as well as a long lifespan, which can be further extended by recyclability, keeps us competitive with the industry standard. Our business development strategy is threefold. First, we aim to validate our technology by partnering with university and co-location data centers to sell our first systems. From there, we'll move on to sponsoring key AI and computing conferences to build our brand name. And finally, we're going to target the most profitable customers in the market, hyperscale data centers, and aim to send our systems to those targets. Our timing can be broken down into two major phases. First, there's the demonstration phase, where we build our relationships with key demonstration customers in the Department of Energy, as well as shipping our first products to customers. From there, we move on to a scaling phase, where we break ground on a high-volume manufacturing facility and complete the development of our recycling capabilities and begin our targeted marketing to hyperscale data centers. Our business has a promising future, while also accelerating the energy transition. Currently, flow batteries are stuck in what's known as the Valley of Death. They lack the public funding that comes from R&D and universities, but they've yet to reach the scale needed to get private funding from major for-profit companies. By proving this technology in this specific use case, where their benefits can be uniquely harnessed, we prove the technology and decrease its cost for grid-scale energy storage. Since lithium-ion batteries are rising in demand, they're going to become less and less accessible for grid technologies. Flow batteries will fit this niche perfectly. So in summary, we provide reliable power at no upfront cost to our customers to accelerate our decarbonized future. We're happy to answer any questions.
Awesome. Just under 3 minutes for questions.
I appreciate that you had a clever business model where you eliminated the upfront capex and created a subscription based. But I'm curious whether that's actually like a major pain point for your customer. I feel like these data centers, what's built into it is sort of the financing around the battery technology, et cetera, today. So what did you hear from customers that said changing the business model was actually one of the key drivers of their adoption?
Yeah, so we saw that because of this growth in the data center market and because these companies are scaling so much, reducing that capital expenditure up front would probably be like a key target for them in order to improve the scalability and to sell to more, to be able to match the demand that they need to keep up with. Because AI and a lot of new technologies are causing these data centers to have to be able to be grown at a much faster rate than has ever been seen before.
Okay, but I heard probably. So customer discovery on that front?
Yeah, that's our next steps. We're moving forward to customer discovery after this.
So I believe there were some pretty famous vanadium flow fires in the past at a larger scale. And I'm wondering if your main change here is the form factor of a vanadium flow battery, or if there's other IP associated with your approach.
So a vanadium flow battery, so the electrolyte is fully water-based, so it should be non-flammable.
So the A123 fire wasn't?
So the fire that we mentioned was from a lithium-ion site where these data centers are using lead acid and lithium-ion batteries in those small package solutions, which as you know are highly volatile.
Okay, so other than just using vanadium flow in a different form factor, is there something novel or differentiated about your approach?
So the business model lends itself to this technology as these systems are rated for 20+ years, and it's able to decarbonize.
Usually these systems are targeted for grid scale because that's the main application. And they have yet to be applied in a system like this. And because of their unique technology benefits, they are very highly applicable to this field.
Okay, so it's not like a new membrane for vanadium flow that allows you to achieve this form factor or something like that?
No, this is a proven technology.
Cool.
All right, I think we'll stop it at 7:55. So thank you so much for that presentation. So something to be said about integrating dead batteries into your business model. They're free of charge. No, it's getting worse if we take this on. We're gonna have a long break for lunch. You'll forget all of the jokes and I can repeat them. So I see some judges making some notes. I see some people coming in, going out, finding a new balance. So we're going to introduce our next team, which is ProPika from the University of Arkansas. Welcome. I'm going to give the judges a little bit more time. I still see some writing happening. I will say I'm very excited that we're in a meeting room that has windows. Sometimes we're in these conferences and have no idea if it's still daylight or not. And so having some daylight just does make me pleased for this long of a day of presentations. But that being said, I'm mostly just filling time. Anyone else have any corny dad jokes? They don't have to be energy related, anything. Okay, Edward's got one.
Why is 6 afraid of 7?
That's a,
788, 79, yeah.
what's the next one on my list? Like literally, after Rice University was why I was 6 afraid of 7. You just took one of my jokes.
Uh-oh, you're gonna have to talk about the temperature outside.
How about a quick PSA for everybody? It's tax day. Remember to get your taxes in.
Yeah.
Thank you.
All right, whenever you're ready.
Hi, I'm Nim Cow, CEO of ProPika, and here with me today is Angel Treat, our CTO, and at ProPika, we leverage technology to create a cleaner, greener, and greater future. Many of us flew to get here today, but at what cost to the environment? As the effects from climate change become more apparent, so do the effects from aviation pollution.
And aviation fuels are one of the top 10 contributors to greenhouse gas emissions. Because of this, government goals and mandates are forcing fuel producers to switch to sustainable aviation fuels, which reduce these emissions by up to 94%. And while they are being produced today, we are at less than 2% of the expected 2030 demand. Biofuels are constrained by the lack of feedstock options available for current technologies. What's used are plant-based oils and simple sugars, but there's just not enough. This drives up the cost and why sustainable aviation fuels are currently 2 times more expensive than traditional fuels. Our patented technology alleviates supply constraints by utilizing cellulose. And cellulose is abundant. It's in a lot of the things that we perceive as waste, like leaves, grass clippings, even recycled paper. So we take this agricultural waste that contains cellulose and we put it through our patented catalytic membrane reactor that converts it into building block chemicals that fuel producers can process down into biofuels. And just to clarify, we're not exactly making biofuels. We're optimizing the front end of their process. What traditionally takes them 3 to 5 days, we can do in just 1. Our target customers are biofuel producers, but we're going to start with the smaller players like ICM Biofuels. They have committed to piloting our technology, given a successful demonstration at a 50-liter scale. And at these facilities, the waste is already there. They use corn. And you know that sliver that gets stuck in your teeth? They can't break that part down. So for a 100 million gallon facility like ICM Biofuels, we can generate up to $60 million in additional revenue just by breaking down this extra part. We've evaluated our technology with other feedstocks like rice hulls and almond shells. And traditionally with the enzyme process, they get about 70% yield, but we're seeing up to 94% with our process. And with such a big problem, you would expect there to be competitors. And ours are GF Biochemicals and Fibonal. The main differentiator here, though, is that we offer more feedstock options because we can break down cellulose. We can do this in a single step. We're more energy efficient given that we operate at lower temperatures and lower pressures. We're non-corrosive since we don't use harsh acids. This not only prolongs the life of the equipment at the facility, but also ensures the safety of the people working on the equipment. We can do this in less than 24 hours, but the reason why our competitors can do this is because they use harsh acids and operate at higher temperatures and higher pressures. We have 3 patents over our technology, and we have the exclusive option to license for all fields of use.
Our business model is based off of 2 revenue streams. We have equipment sales as well as service contracts. Initial equipment sales are necessary to implement our technology, and we estimate this to be $5 to $10 million, depending on the size of the facility. For service contracts, this is primarily to service the catalytic membranes. Over time, the catalyst may be consumed, or the membranes may foul up. So when that happens, we'll swap them out for a fresh one. The old ones get sent back to us where we regenerate the catalyst, and then we'll clean them off, and they'll be ready to go for the next customer. This allows us to recycle these membranes indefinitely as long as we don't damage them, so it makes us much more sustainable. For the service contracts, we expect these to come in at $3 to $6 million per facility per year. Again, depending on the size of the facility, Based off our customer discovery interviews, what we found is that for this type of service contract, it's about 10% of the additional revenue that can be generated by implementing new technologies. So we expect that these facilities can generate an additional $60 million in revenue by implementing our process. And so when we broke down the market, we looked at equipment sales and service contracts separately. And this is based off the 1 billion tons of agricultural waste that's generated in the US annually. And so to process this amount of material, we expect that we would need over 1,600 installations of our technology. And this amounted to a total addressable market for equipment sales of over $16 billion. And for service contracts, it was nearly $10 billion. For the serviceable addressable market, we looked at the 100 biofuel production facilities working in the US today. And for the obtainable market, we looked at the 10 facilities closest to us, which amounts to $100 million for equipment sales and $60 million per year for service contracts. Based on these revenue streams, we expect to have our first customer in 2026 generating $6.5 million in revenue and $80 million, or 8 customers and $80 million by 2028, and having $34 million in operating income. Based off these projections, we expect to break even towards the latter part of 2026. And then in order to meet these objectives, we're currently using non-dilutive funding to drive through to validate the technology and drive through demonstration scale. We raised a $1 million seed investment round, along with additional grants to get through pilot scale, as well as our initial customer trials. And so going back to that seed investment, we've already got $500,000 secured with a lead investor, and we've got a 1.2 million gallon pilot facility that's ready to go that we have access to. And then also our relationship with ICM gives us access to a third of all the ethanol producers globally. This is over 8 billion gallons of ethanol capacity. And so this gives us a significant advantage in reaching out to some of these customers. And then in terms of exit, our most likely exit is through acquisition. We looked at publicly available data as well as peer data to estimate our valuation in 2028. And we expect it to be a little over 5 times EBITDA, which comes out to $171 million. This is a significant return for our early investors and puts us under the umbrella of a larger company with the resources to allow us to grow and expand even faster. And so here at ProPeca, we have the right technology with the right people at the right time to create a cleaner, greener, and greater future.
2 minutes and 10 seconds. Questions?
Just clarify, so would your, I guess, equipment that you're installing, is that sort of drop into existing ethanol plants, or does it have to be from?
Yeah, it is. It's a bolt-on technology. We're just adding on for where their waste is generated at.
Are there existing supply chains for all of these feedstocks that you can use? So you were mentioning the one facility already has sort of the corn silk, but I'm wondering how heterogeneous the other feedstocks are and what that means operationally.
Yeah, generally it's corn though that they use, but we can, as long as it has cellulose in it, we can use just about any of them. But yeah.
Still have about a minute for questions if anyone else has one.
Yeah, I guess I probably still just need to clarify. So are you, you said you were an input into the biofuel production process. So who does that make your customer? And what's the relationship with the AGM Biofuels or whoever they were? I might have the acronym wrong.
So with ICM Biofuels, so they're our customer. And so we'll provide them the catalytic membrane reactor. And what they're going to do is, for them, what they're producing today is bioethanols. And so to create more value from what they're already bringing in, the corn that they're bringing in, being able to process the corn fiber into sugars that they can ferment increases their output of ethanol.
But that's one customer. So all the other customers you would have would all still be biofuel producers?
That's what we're targeting right now.
Okay. And so what was the relationship you talked about with them getting to, you talked about it being a further benefit.
Yeah, so
just about the scale, is that what you're trying to get to?
Yeah, so ICM Biofuels has a plant located outside of Kansas City in St. Joseph, Missouri, and they're excited about what we're doing, and so they've said that if we get up to 50 liters scale, they want to pilot it. And the benefit that we have with them is that they have a 1.2 million gallon pilot plant that's sitting idle right now that they would love for us to come in and use.
Thank you.
Awesome, thanks so much. Yeah, it's always nervous. Like, is it going to roll right off the table or not? So my next joke was, I was afraid of 7.
7, 8, 9, but someone used that up. But at a renewable energy conference, there's a wind turbine and a solar panel introducing themselves, and the wind turbine comes up and says, "Hi, I'm a big fan of solar." Maybe, maybe not. So we have, it looks like, 11:35 to, nope, 11:25 to 35 is our next team, and then one more after that. And then we will go down to the third floor for lunch, and then from 1 to 1:30 will be the keynote speaker and welcome to the Energy Thought Summit overall. So we do have a nice break for lunch and that opening keynote. I highly encourage you to attend that. While you're on break, if you have presented, please do give us some of that feedback so that we can continue to improve in the future. But as we go through there, our next team is going to be Zpryme from Rice University. So if you are here, coming up, great. Then we will get going in just a moment. I think we're getting this process down. I think we know how it's working. So, just you?
Yep.
All right, there you go. All right, looks like we're ready. Welcome.
Hello. Hi, everyone. My name is Maximilian Kovas. Very excited to be talking to you all today about how we at Zpryme have developed a next generation technology capable of directly extracting lithium from wastewater streams. Now, there's no surprise that our society is heavily dependent on technology, as our phones and laptops have nearly become extensions of our physical selves. But as demand for these electronics and electronic storage continues to increase, so does demand for lithium, which plays a critical role in high storage batteries. Now, lithium demand is expected to increase by 500%, while projections suggest that we are going to experience a 500,000 ton deficit of lithium, which has caused the price to soar from $3,000 to $20,000 per ton. Now, this surge in the cost of lithium presents a unique opportunity for businesses to capitalize on the lithium present in their wastewater streams. On a daily basis, over 2.9 billion gallons of produced wastewater are generated by oil and gas companies, which contain lithium that, if recovered, could greatly offset their discharge charges by more than 50%. However, this opportunity has yet to be capitalized on, as commercial technologies are unable to recover this lithium at these lower concentrations in a cost-effective and efficient manner. Until now, here at Zpryme, we've developed the LESET system, which can recover lithium directly from these wastewater streams using our patent-protected membranes and electricity. Driven by the electrodialysis mechanism, our energy consumption is greatly reduced. Thanks to our specially tailored extractant, that's what I was missing. Moreover, our system is very versatile and can treat a wide variety of solutions, ranging from low concentrations of lithium all the way to highly concentrated surface brines. Actually, using our technology, 1 barrel of Texas brine contains enough lithium to manufacture 48 iPhones. Furthermore, our technology is completely sustainable, requiring a negligible chemical input and actually capturing carbon dioxide in the process. And lastly, our green system is modular and designed with commercially available materials and industrially matured manufacturing processes, meaning that our system can be easily scaled for larger applications. But how do we compare against competitors in the industry? That is a good question. Well, firstly, not only can we recover higher percentages of lithium in much lower concentrated streams, but compared to conventional evaporation methods, we require significantly less time and area footprint. Now, compared to absorption processes, our technology completely negates the regeneration process, which greatly reduces our chemical cost, freshwater consumption, and waste. So what can we gather from this information thus far? 2 things. Firstly, our technology outperforms the competition. But secondly, that we've identified a select market need that only our technology can address. And that being that we have businesses
oil and gas or geothermal, that contain lithium in their wastewater streams. And they're already paying hefty sums to discharge these waters. By utilizing our services, the lithium present in these streams could be recovered and greatly offset these sums. Now, through a formal service agreement, our clients would give us access to their wastewater streams, and we would provide our services and technology. And our revenue would come from two streams. Firstly, an upfront service fee of $7 per meter cubed of treated volume, which is actually very comparable to what they're already paying for discharge. And secondly, a share from the lithium revenue sold downstream to battery manufacturers. Now, this is actually very desirable for both parties involved, because not only does Zpryme benefit, but so do our clients, who achieve a gross margin of 31%. With over 400 potential clients in the industry, growth for our business is vast. So our scaled up projections suggest that by attaining or recovering 2,500 tons of lithium carbonate per year, taking in conservative assumptions into account, like the cost of lithium carbonate, we anticipate an annual revenue exceeding 30 million, while attaining an operating profit of 10 million, while staying at an operating profit margin of 27%. Now, to help reduce risk and commercialize our business, we've adopted a stepwise approach, which, as it sounds, help us build up step by step. Now, in accordance with this approach, we're currently asking for $2 million to help develop and deploy our first demo system by 2026 on site at the clientele's wastewater to help demonstrate our versatility. After this, we are confident to raise enough funds to launch our first commercial scale plant in 2028, by which we anticipate being financially sustainable and achieving positive cash flow with a payback period of 4 years. At Zpryme, our vision is a secure electric future with affordable green energy for all. We're cutting it close. Our team has the necessary expertise to make this vision a reality. Please join us as we lead the charge for an electric future.
Exactly 2 minutes. That's about 2 minutes.
Talk me through the operations of your system, like what happens at the site where there's water being discharged, what happens when it goes through your system, and then what happens?
Okay, yeah, so I'd like to use a comparison between us and the ion exchange for the absorption process. Like for the normal or conventional absorption process, after the pretreatment to get all the organics out, solids out, they will first do the absorption. They need to adjust the pH for the absorbent to be in the best performance and will absorb the lithium ions, and then if there are absorption, they will need a large quantity of water to get it dissolved. So if there's a ion exchange, we need a large amount of the acid to get it out of the rising. And after that, they need to refine it because the concentration they get is not ideal. So they still need to do the concentration process, which they are currently using as evaporation, but mechanical evaporation to get the lithium into the higher concentration, and then they will send that high quality lithium stream to the like post-treatment side. But for us, when you give us the pre-treated water, we will take care of all of them. So the water will go into our module, and we can do the selective ion transport. Only lithium will go through from the one side to another side, while we reject the calcium, magnesium, so the scale their impurities. Here we directly get the high purity lithium stream, and that is the ideal feedstock for the post-treatment and for the precipitation.
All right, about 30 seconds for one last question.
Why rely on pricing in the market instead of just charging your customer a flat fee to convert the brine to lithium?
So that's actually a very good question, but being how versatile the price of lithium carbonate is, so we've seen it go all the way up to maybe 60,000 per ton, all the way down. We would definitely like our clients to want to take on our technology. So like we said, through that formal service agreement, definitely having a discussion in there would make it most profitable for both parties involved, would be desirable.
Just a word of thought, if you can fix your pricing, will be a lot more attractive to investors.
Oh yeah, 100%. Any investors in here, it's fixed now.
So, thanks so much, and really appreciate that presentation.
towards the point of view of, are there any investors here? You may note that most people in this room right now are your competitors, which is great. But at the Energy Thought Summit, there are about 400 people here from large utilities, from the investment community, from large engineering firms, other relevant activities. So I encourage you to spend your time during lunch, during the breaks, over the next couple of days, if you're able to stick around, talking to other people. So it is useful. It can be hard, it can be scary, but go talk to other people. You are here, they're here. It's an opportunity, even if they're not your customer, to think about what is your quick elevator pitch is something worth doing and talking to everyone else who's here. So there are investors in this room. There are investors in the building. There are investors at other universities, or maybe it's the next opportunity for you as a person. Something we talked about with this program really focused on education is where do you go next? So maybe this business plan finds traction and does great, but more likely is that you find traction and do great. And that's how we're going to measure our success from the Department of Energy, is where all of the students go as individuals. So really take this advantage to learn, experience, and grow towards that point of view. I did not have a joke for this break, so I just filled it up with other content. And with that, our last team before our lunch break is EcoGrains from the University of Notre Dame. Welcome. That's
embarrassing.
More. Just change everything around. All right. I think we're set. Welcome.
In 2016, our planet had the highest concentration of CO2 in the atmosphere in 3 million years. Fossil fuel usage is the #1 contributor. The US in particular has a goal to reduce greenhouse gas emissions by 70% by the year 2030. That's 6 years away. That seems like an almost impossible goal given the infrastructure in place today. EcoGrains can help make this a possibility. Currently, the US is a leading producer of bioethanol globally. All you need to know is that the market is huge and it's growing rapidly. Let's take a look at the current bioethanol process. Biorefineries take in corn and produce 3 main products: ethanol, distiller's oil, and finally our main focus, distiller's grains and solubles, also known as DGS. DGS is currently sold as a low-quality animal feed to farmers. Here's a picture of us visiting a mid-sized biorefinery called South Bend Ethanol. They produce a lot of DGS. Those jars in front of you were produced in less than 60 milliseconds. And that mound behind us in this picture was produced in an hour. 60% of this DGS is put onto boats and shipped to countries like China, producing even more CO2 in the environment. We spoke to 50 people in the industry, and we learned that there was a clear need and interest to innovate around DGS utilization. DGS is currently undervalued and underutilized in the US. We see it as more than just a low-quality animal feed. We see it as a pathway to net zero. We are licensing our technology from Sandia National Labs to reimagine DGS utilization. Our technology allows for the simultaneous conversion of both sugar and protein fractions of DGS into isobutanol, our desired product. Isobutanol is a chemical intermediate used in a plethora of different industries, including as a fuel additive for sustainable aviation fuel, also known as SAF. And this is done through our one-pot bioconversion process, which is a 3-step process. First, we have the pre-treatment step, which allows the breakdown of those fractions. Then we have a 52-hour fermentation with our E. coli cold culture system that was genetically modified through plasmid integration. Then lastly, we have the alcohol fermentation products extracted from our biomass. We can create 33% more fuel from the same amount of corn than compared to the previous process.
So where do we create value? Currently, the industry works by a given refinery taking in a ton of corn. From that ton of corn, they produce 107 gallons of bioethanol and 551 pounds of DGS. As it stands, they sell this to farmers as livestock feed for $43. That's a market price of about $160 per ton. With the addition of eco grains, we changed that same DGS into 200 additional pounds of isobutanol, sell it for $204. That's a market price of $2,000 per ton. We've effectively 5x this profit margin and unlocked 371% more revenue from the same amount of DGS. This is awesome, but how are we going to get there? We've developed a 4-phase scaling plan to take Sandia's technology from the lab bench to the industrial setting. Our target market lies in sustainable aviation fuels, but we need to be at a huge scale to enter there. We know we need to start small. So in that spirit, we've explored alternative feedstocks for our process and have found that whiskey distilleries' spent grains offer a viable alternative. That leads us to phase 1, in-house manufacturing and a partnership with a single small batch whiskey distiller. We received a commitment from Indiana Whiskey Company to provide us with 750 pounds of spent grain per week for us to process into isobutanol. Phase 2 is linear and local expansion to 10 other local distilleries. Here we bet the scale of 8,000 pounds of spent grain per week, selling our isobutanol into our beachhead market and specialty chemicals. Phase 3 is a huge jump. We're moving manufacturing on site. That looks like a partnership with a large-scale whiskey distillery where we'll establish ourselves on premise. Here we'd be at production scale of 160,000 pounds per week, and we'll finally have de-risked our technology and proven our on-site manufacturing schemes so we can enter into phase 4, our first partnership with a bioethanol refiner. Here we'd be at production scale of 2 to 4 million pounds of DGS processed per week into isobutanol to be sold as an additive to SAF manufacturers. So what is our impact? We'll be operating in the Corn Belt region, a historically economically disadvantaged area. Take, for example, our home city of South Bend. There, the unemployment rate is nearly a full percentage point higher than that of the national average. If we headquarter in South Bend and expand into similarly disadvantaged regions in the Corn Belt, we can boost those local economies and bring jobs to those areas. In a perfect world, if all aviation fuel was sustainable, we'd have the ability to cut emissions in the sector by up to 80%. As recently as 2 weeks ago, the Biden administration put out a goal to produce 3 billion gallons of SAF annually by 2030. If we really want to reach net zero, we need to be producing 118 billion gallons annually by 2050. We estimate that if we partner with 20 refineries by that time, we would enable the creation of 5 billion gallons of SAF annually and cover 4.2% of that requirement all by ourselves. We realize that we can't do this alone. We need to work alongside industry giants like Poet and Gevo, alongside SAF startups that we've heard pitch earlier today. We believe in being a force for good and fixing things that matter. Help us in our mission to decarbonize a hard to decarbonize industry.
Thank you so much.
You mentioned that your first beachhead market was going to be specialty chemicals. So what's the value proposition to them? Is this just like a better cost because you're able to do it at 5 times the profit margin?
So we know that ours is cost competitive compared to a synthetic, but they have that added value for their customers of being bio-based. So they can say now to their customers, we're bio-based, and that allows them to get more value.
But do you have evidence of that? So like who's the customer of a specialty chemical company and how much pressure are they putting on to have bio-based? Is there regulatory pressure or what's actually causing them to choose bio-based?
So there have been mandates in place pressuring the industry to move towards bio-based. So that's kind of the main reason why they'd be interested in this.
Is there something particular about the whiskey spent grains that are different from other kinds of spent grains that'll cause you to have to specialize? Or are you going to be able to expand your supply as you move along?
Yeah, so it'll be dependent on each in particular distillery, but typically their mash bills are upwards of 70% corn. So percentage-wise, the difference from what the bioethanol refinery is taking in is not much different. We have a close relationship with the inventor of the tech and asked them about the feedstock variability there. The other grains that go into the process are things like rye, wheat, and barley. They have different protein and sugar and carbohydrate makeups, but our estimates right now is that we actually could increase yield using that different feedstock.
Anything in 20 seconds? Very quick question. If not, thank you so much for your presentation.
Thank you.
All right, so I am correct in understanding that it is now lunchtime. So thank you all for hanging out with us this morning. If you have presented, please find one of those feedback forms or use the QR code to give me some feedback on what we could do better or give me some other dad jokes, and go have some lunch. And we'll be back here at what time, Jackie? 1:30. So come back here 1:30, or their session should end at 1:30. I think we start pitching at 1:35. So you'll have to come up here quickly after the main session ends. Thanks so much, everyone.
The judges don't get a break.
We are not breaking.
That was a
So,
rebranding,
from
yeah.
3 sorry, from 3 to like 4:41, we have the most difficult problem, so that then we can go down to that very big room that some of you were just in for lunch or for the keynote session. And that's what we're going to join right at 4:55 as they wrap up, and we'll announce our winners at that time. So it'll be with the rest of the conference attendees in that session. But again, the judges don't actually get a break from 3 to 5. We have to do all the hard work then. With that being said, welcome back from our break. Jackie, if we could bring up the next presentation for Derek Maxwell from Northeastern University and Propriety Inc. Welcome. Thank you, Jim.
Hi, everyone. My name is Derek, and I want to talk to you today about something we all have with us each and every day in our phones or batteries. But let's imagine something different here. Imagine that you actually had to build this battery. Imagine that you walked into the factory floor, you're suited up, and now you have to go work with the chemicals that are made or that you use to make the battery. What if I told you that they were toxic materials? You walk in, maybe you smell it a little bit. Unfortunately, these materials, the solvent being a fluid is called NMP, and the binder, which holds the battery together, is called PVDF. These materials can cause cancer and reproductive toxicity. And the binder is actually made with PFAs, which we are starting to learn more about, are toxic forever chemicals. It's such a big problem now that the EPA recently came out and they said that NMP, which is the solvent, presents an unreasonable risk to human health. And the ECHA, the European Chemical Agency, claims that if we do nothing about this problem, some of our natural resources will be rendered unusable indefinitely. And there are bans that they're looking at instituting globally. Is there a solution yet? There is. My company, Propriety Inc., will replace those binders and solvents with non-toxic materials. This generates 2 revenue streams for our business. But what's unique about our value proposition is that generally when a company wishes to go green, sometimes that induces an extra cost. We can actually save them money while they go green because our materials are cheaper. The process was invented by myself and the patent is owned by the company. So in part 1 of the solution, we're replacing the NMP with Bio-Solvents. And these are fermented from corn, for example. Bio-Solvent is non-toxic, it's 50% cheaper, and only made in the United States right now. There's a $2 billion global market alone for solvent replacement. We can also reduce greenhouse gas emissions by 42% by making this switch. Please note that Propriety will license the technology, the ability to use the solvents and the binders that we patented, and we are not a manufacturer or distributor. The second part is to replace PVDF with safer binders. Our binders are PFA-free, also made in the United States, and these ones are 10 times cheaper. We could also leverage the National Lab Partnering Service as an option because some of these polymer binders may be compatible with our biosolvents. Here's the typical battery manufacturing process. The one to pay attention to, this step is called slurry mixing. This is where we make the switch. We change out the solvent and the binder here. No new equipment downstream is needed. This is a true drop-in replacement. Only the slurry formula changes. There are many different innovations to our product line. Chief among them is that a biosolvent-based battery could be recycled with water. We identified no existing US or European competition. We have one competitor based out of China, but their solution is complex and requires additives. Ours is much simpler and easier to implement. Our market can grow to $4.5 to $5 billion, which is 800,000 tons of solvent alone by 2030. We license to all lithium-ion battery manufacturers independent of the segment. And partnerships are key to our business model. What we do is we approach the battery manufacturer, they are the customer, and we license the technology, the know-how, the ability, and the rights to use the solvent and the binder. We further connect them with the binder and the bio-solvent suppliers. So in this role, we're a facilitator. And to collect revenue, we charge a recurring license fee. This is based on the cost savings or the value we bring to our customers, and this can track with the size and growth of the battery market. Now, for example, we could save one gigafactory $70 million a year just by making this switch. 15% of that is $10.5 million of revenue per year. We're targeting about $1 million in revenue by 2027, and we plan to keep our customer acquisition costs low because we leverage the partner facility. We stay lean on operating expense because we also have no in-house manufacturing. In the first 2 years of our traction and long-term plan, we've met all of our milestones. And so far, no grand surprises outside of this competition have been awarded. The biggest accomplishment is that we did file a global patent for the material usage, and this is critical to the licensing strategy. In 2025, we're looking to pilot test and start a capital campaign where we need about $1 million to continue our operations. In 2026, we're entering production testing with a large battery company. And in 2027, we're looking to expand our IP licensing and enter the European market. A little bit more about myself. I have 10 years experience in energy storage. I've worked on DOE and SBIR projects, and we recently added a regulatory specialist and possible co-founder to help out with the business. With that, I thank you and look forward to your questions.
About just over 2 minutes, 20 seconds for questions.
You mentioned your proprietary solvent. It works. Turn it on. But you didn't talk about what was proprietary about the binder. You just said you were going to replace it with a cheaper one. And so can you talk a little bit, do you have IP around that too? And
yes.
Why is it not, what's going on with that?
So we own the IP around the solvents that are used and the binders that are compatible. So one caveat is NMP is the starting material. Our binders may or may not work with them, but PVDF, the binder that is ubiquitous now, does not work with bio-solvents. So we found that there was a secret there, that we could actually save costs on the binder as well as the solvent.
Because of the solvent.
Because the solvent needs a different binder.
Okay, yeah, okay, got it, thanks.
So have you proven this out with partners, or is it still at the lab?
It's still the lab scale. We're about a TRL4, so I've made batteries, they do work. And what we're doing is we're bringing that data in DEX to our target customers. So we have a couple of companies that I've signed NDAs with. So we're in that customer acquisition kind of sussing it out phase.
Okay, and have potential customers told you like what the threshold would be for them to adopt your solution?
Threshold in terms of?
Like, what are they looking for in a solution, and what would the path be for you to demonstrate that to them?
So I think part of this, maybe I didn't iterate it enough, is that the regulatory push is coming and there's no current alternative. So we've talked to them and said, look, like, we know this is going to be an issue for you. Are you interested in an alternative? And they always say yes. And they say, what's the catch? Well, then I say, we save you costs. And they said, when should we try it?
Great. So you mentioned your batteries work. What kind of comparability studies have you done? Can you tell us a little bit about that?
Right now we're at the coin cell. This is benchtop, very small scale. So we've proven out the concept that we can mix, we can coat, we can make the full battery. And we actually went and we found a incubator space at UMass Amherst. So what we do is we can actually scale up in-house. There's a roll-to-roll facility, so we can prove out to our customers.
Yeah. I would just encourage you to do those comparability studies, get those started as soon as you can.
Yes, that is actually all of this year is R&D.
Yep.
Awesome.
Thank you very much.
That's all you did. Appreciate that. So I did have a joke about recycling, but it's been used. And Danny has given me a few extra ones for this session. How does a kitchen say hello? With microwaves. All right. Let's see some eye rolls. That's all right.
I'm
We're going to do
chuckling.
this activity.
So our next team is going to be Geo at MIT, team from MIT. Welcome.
And we'll, looks like judges are still writing. Did anyone look up energy jokes during the break? No? Is that how you spend your free time?
We didn't want to steal your joke.
That's true. That was pretty upsetting when Edward took my
Actually,
6,
Jeff,
7.
Joe, could you just say who Jeff is?
Oh, yeah.
I think
So that's a great point. So I don't know if anyone's really been paying attention, but every once in a while, Edward has swapped places with Jeff, who is also from the Office of Technology Transition. So the teams that Edward has met with, he's not going to directly judge, just to make sure that we're equitable there. So very quickly, Jeff and Edward have swapped places. And that was a good way to use it up another 30 seconds. Appreciate that. All right, on to you.
Hi, my name is Jason. I'm a junior at MIT. Our team is excited to present an advanced thermal storage GDHC system to decarbonize universities. Buildings contribute 42% of greenhouse gas emissions, and clusters of buildings, like universities, can contribute twice as much carbon per person than average commercial buildings. For example, MIT and Harvard contribute 38.8% of all Cambridge citywide large building emissions, and as much as 97% of these emissions come from building heating and cooling. Universities themselves have recognized this problem and have made goals to decarbonize by 2050. However, they are uncertain of how to reach these goals. The main barriers are the affordability of the technology and the need to minimize disruption to campus activities. To address these concerns, our team has identified a systems design combining geothermal heat pumps with thermal energy storage to offer a cost-effective, low-risk approach to HVAC systems. Our approach utilizes a system of 3 core technologies to increase efficiency and reach zero carbon goals. A network of water source heat pumps installed at each building can transfer heating and cooling across buildings through a shared water loop. In one building, another building that may be heating can recycle the waste heat for free. Next is an exhaust recovery system that recovers wasted energy that can either be used in the heat pumps or stored in thermal batteries. Thermal batteries store extra energy when energy demands are low and cheap. When demand is high and energy is pricier, they release that stored energy back to the heat pumps to meet the building energy loads. This cycle of storing and releasing heat energy increases efficiency and reduces the use of electricity from the grid. In comparison, existing HVAC systems at universities can never reach zero carbon, and alternatives on the market are either too expensive to operate or don't have that climate impact needed. We are targeting 50% of US academic institutions in our total addressable market. Our focus currently is the 337 colleges that have committed to net zero by 2050. To address upfront capital expenses, we retrofit existing piping networks as much as possible. But we're also partnering with banks to lease out all equipment for universities that may have smaller endowments. Lastly, we leverage federal tax credits and federal funding available to us. And at MIT, this could be as much as $75 million. These strategies help reduce the initial cost barrier that may prevent some colleges from considering decarbonization. But implementing our system also has significant operating expense savings. Water source heat pumps are currently the most efficient commercially available heat pump, with efficiencies 4 to 6 times greater than electric boilers. And the life cycle of a heat pump is 25 years. Since this system is decentralized, repairs can happen on-site quickly and won't disrupt campus at large. Additionally, an estimated 25% of HVAC needs will be eliminated because of the ability to share energy between buildings. With these savings, we estimate a 20% reduction in annual electricity usage at colleges with a payback period of less than 10 years. Our implementation strategy has 3 phases. We first approach universities and offer a top-line assessment of their HVAC systems. To expedite this process, we're developing modeling and simulation tools that will illustrate the energy savings and emission reductions. If the university wants reassurance, we'll offer a small pilot project on their campus. And our team has recently received approval for a project like this at MIT. At the same time, we'll develop financing plans and connect them with the relevant construction firms to manage the installation on campus. To minimize the campus disruption, we're going to go through with a phased approach, where incremental HVAC upgrades happen through one building cluster at a time. This is a map of MIT's campus and their building clusters, and our pilot will occur at the black circle. Our team is bringing together an ecosystem of universities, firms, and banks. To start, we believe our company needs 3 full-time personnel and 3 part-time senior advisors. Our financial model is based on generating revenue from commissions of successful completed projects, selling our licensed tech IP to other firms, and consulting fees. Initial funding will come from outside capital. We've already received preliminary interest from a private investment firm for $10 million with interest in our highly profitable multi-year leases. And with this capital and leasing, we believe we can be cash flow positive in 3 years. To scale up our awareness to other colleges, we're building educational programs and training programs for firms and universities. And this outreach is already underway at Wellesley and Harvard. And we're looking to expand to the greater Boston area soon. Once the modeling tools are developed and we license our IP, decarbonization can happen even faster. And lastly, we'll continue our ongoing efforts to partner with highly influential universities with high emissions. And our design is also affordable for disadvantaged communities. Historically, Black and minority colleges are disproportionately burdened by HVAC upgrades, and our partnerships and advanced design will ensure that they're not left behind. This initiative also empowers students to take leadership roles in the energy transition. So we hope that as universities are centers of science and innovation, that they will take a leading role in decarbonizing the world. We hope that our work will inspire other students to join the cause of rapid decarbonization at their campuses. Thank you, and we'll take any questions.
Thanks so much. 2.5 minutes for questions.
You had an opportunity to speak with any of the banks or other financing groups to kind of find out what kind of terms they might be.
Yes, we have. I don't have the numbers off the top of my head, but they are willing to give us a 3-year opportunity to basically do what we can with the $10 million. And then after that, they will reassess. And if it is successful, we'll take a 1% commission. And so if it's $500 million, we'll get, sorry, I'm really nervous. I can't do the math, but we'll get 1% of that. It's a lot of money.
Then have you guys spoken to companies like Trane, Daikin, a lot of these HVAC companies, right, who go out and do projects, if they would be willing to take on your solution?
Keep going. Oh, that one. Yeah, right now we actually have a board of advisors and experts who are own HVAC companies themselves. And so the Gray Edge Group, David Williams has his own HVAC company. Urbana also has its own HVAC company, and they are the company that will be doing the pilot at MIT. So we have connections to industry experts that will give us that.
They have a combined experience of 250 plus years in HVAC, and some of them are already on the board of ASHRAE.
Can you go back to explain the business model again? I'm unclear. What are you, a services business? And what specifically is the IP? Because you're not actually implementing the HVAC system. You're just the approach. So what keeps the HVAC companies from starting to just offer this kind of model?
So actually, our HVAC experts own the design. We've already licensed the intellectual property. And a key thing is that most traditional HVAC engineers are not familiar with this design, which is why we are currently the only people with this kind of proprietary information, and we're looking to share it with other people. We'll be actually presenting at ASHRAE this June, and I'll be presenting at another conference for this information.
But therefore, sorry, it's so loud. Your IP then is in the design, and
yes, exactly.
And so it's an issue of protecting that design.
Go ahead.
Yeah, so we plan to sell the IP so that we can accelerate this to other consulting firms. So that right now the problem is that they're aware of only up to 4th generation HVAC designs, but we're looking at 6th generation HVAC designs. And so at MIT, for example, whenever we're MIT and other consulting firms that we've been talking to, because we're doing a lot of stakeholder interviews, we're finding that not many people are even aware that this exists or how to do it. There's only about hundreds of people in the United States who are certified geothermal exchange experts. And so it's very untapped.
All right.
Thank you.
Thank you so much. All right. Thank you so much. So let's see what I got here. What did the volcano say to Earth? I'm going to explode if you don't stop pressuring me. That one was not good. It was great. Thank you. I heard that. Did you know there's a lot of teams presenting? There's a lot of teams in this notebook. But thank you so much for that presentation. And what runs but never walks? Water. So our next team from that subject is Samantha Jasundra and Jessica Beck from the University of Michigan. And it might have something to do with water. Maybe. All right, welcome.
Hello, everyone. I'm Jesse.
And I'm Samantha, and we're COMPScan, the marine energy solution for coastal communities vulnerable to climate change. Climate change has caused rising sea levels and warmer ocean temperatures, which have increased the frequency and intensity of natural disasters. In the US alone, this 3 times increase in natural disasters has cost trillions of dollars in damages, thousands of lives lost, and major power outages. Coastal communities are especially at risk, and it is up to us to be prepared.
This is where COMPScan comes in. COMPScan produces marine energy converters inspired by kelp. Artificial kelp strands twist and bend in the water to generate electricity. Developed at the National Renewable Energy Lab by Dr. Nicole Mendoza, this technology can be thought of as an artificial kelp forest that's customizable by shape and size in both freshwater and saltwater.
COMPScan forests provide many of the same benefits as real kelp forests. They trap nutrients to support ecosystems and reduce waste stream. Since they reside underwater, they're not susceptible to damage caused by tsunamis and extreme weather above the surface. They have an expected lifetime of 20 to 25 years and inexpensive production of just 50 cents to $1 per strand.
In the case of a natural disaster, COMPScan electricity can be used for emergency purposes when the main grid goes out. Just a 10 kilowatt installation can provide enough power to produce safe drinking water for almost 11,000 people.
Let's look at the market for this. COMPScan resides in the marine energy market. Marine energy, which generates power through the natural movement of water, is a severely underutilized resource in the transition to clean energy. Due to its accessibility and high energy potential, we need change makers to invest in marine energy technology now. Zooming out to the renewable energy market overall, you can see there's currently no other technology that does what COMPScan does to address both pre- and post-disaster conditions for isolated communities, promising reduced waste sink, simple installation, and increased resilience to extreme weather.
To mitigate startup costs, COMPScan plans to secure partnerships with large industry players. General Electric and Honeywell have a history of investing billions of dollars in sustainable solutions for energy reliability. Other primary funding sources include local major utility providers in Hawaii, the state we plan to launch in, that have a multi-million-dollar green bond framework supporting Hawaii's 100% renewable energy goal. The US Navy also funds research in state labs and universities.
The cost to test and develop the electrical components to achieve an MVP for COMPScan's artificial kelp forest is $250,000. The billions of dollars available for renewable tech from these aforementioned funding sources can not only easily cover MVP costs, but also years of development.
While COMPScan's benefits to collective humanity are truly priceless, investors can also expect a return from our 2 main revenue streams when the product is commercially available. So providing electricity either through major electricity providers or directly to businesses and communities that are interested in resilient off-grid power.
Given Hawaii's tsunami vulnerability, lack of immediate access to mainland disaster relief, deteriorating marine ecosystems, and current petroleum dependency, the state is an ideal location to launch. COMPScan recognizes that entering into communities must be done with respect and consideration for the history, culture, and wishes of the Hawaiian people. To ensure that we benefit our stakeholders, we want community members involved at every step. In particular, partnership with the University of Hawaii will bolster social engagement and educational impact. There's already overwhelming support for marine energy research in Hawaii that COMPScan plans to use to refine our MVP. These 2 sites alone have the largest seawater supply system in the world and the country's first open water, grid-connected wave energy test facility.
The next step to commercialization is to launch a small-scale pilot project with a community grid system. So community grids are microgrids and nanogrids, and they're local sources of electricity that operate separately from the main grid. Their market is rapidly growing as consumers aim to avoid the impacts of major power outages. So COMPScan will work with the aforementioned industry partners to develop a joint forest grid system, and this is what we'll be commercializing. So COMPScan will produce and install the kelp forest while the industry partner connects it to a nanogrid. This pilot project will better define system capabilities and maintenance requirements under real ocean conditions and improve power density, durability, coastal resilience, and cost.
Given these resources and your support, COMPScan would be ready to launch a pilot project in a year. The next steps to commercialization are establishing a reliable supply chain and streamlining manufacturing process to reduce production costs for full-scale deployment.
COMPScan defines success as contributing to the U.S. Department of Energy's Powering the Blue Economy initiative by sustainably supporting resilient, population-dense coastal communities. In combination with isolated community grids, COMPScan's forests can fortify energy reliability, extreme weather preparedness, and disaster relief, all without relying on fossil fuels.
We envision a future where CalcNext's global deployment connects industry leaders, educational institutions, and historically underrepresented groups. So join us in building an inclusive, energy-resilient future in the face of climate change to care for both our people and our planet. Thank you.
2 minutes, 45 seconds for questions.
Thank you, ladies. Great job. One thing I keep thinking about is each frond is only producing how much?
1 milliwatt as of right now, but that is at TRL3, so very early in the research phase.
Okay, so the scale up would not be the number of fronds that are deployed, it's the actual size of the frond. Is that what you're saying?
It could be either. There are definitely differences in how much electricity it will produce based on like length of the frond, for example. And even like where in the water, what type of body of water it's implemented in. However, we expect, and the developer of this technology from NREL that we spoke to has confirmed that the power density will increase as like more funds are poured into research. But it also can be scaled up by number of fronds if you want like a larger installation to serve a specific community.
Could you perhaps explain a little bit more about why the kelp frond is particularly good at, capturing energy in the ocean relative to other kinds of implementations? We didn't hear anything about why. We heard about the sort of side benefits of it being like kelp, but what about in terms of its energy generation?
Sure, I can take this one. So the fronds themselves are able to be deployed in many different types of bodies of water. So as we were kind of looking for our commercialization plan, there are definitely future opportunities to go in ocean environments or rivers or lakes. However, we wanted to begin with oceans because the strength of the waves we believe will have like the largest conversion from mechanical stress endured by the fronds to actual electricity generated. Also, there are like lots of benefits to Hawaii, particularly in a lot of coastal communities, because we're coming at it from this disaster relief standpoint. And they're particularly vulnerable.
Yeah, you asked from a electricity generation standpoint, and in addition to that, I know this wasn't your exact question, but we really do believe that this technology, compared to other marine energy technologies, are so important for the additional benefits we've mentioned. They're specifically designed to boost ecosystems. They can reduce wave strength from our disaster relief standpoint that we're coming at. And compared to other wave energy converters, they're way more easier to install. They're not big monolithic structures. They're customizable. You can take them apart and install them directly there in whatever body of water you're.
All right. Thank you so much.
Thank you.
Thank you.
It's gonna roll off. That's it. Solve it by the end of today. So why do transformers hum? They don't know the words. All right, it's getting tougher. It's a tougher crowd. I might just have to leave these behind eventually. I have another one from Danny that I'll say while the judges are making some notes. Why are wireless appliances bad at music? They don't use any cords. No. All right, that one was better. It's gotta be tough to be like a stand-up comic. Like, that's gonna be a really tough job. At least I'm just filling time, but not trying to like make a job of this. Man, that would be a very tough job. To be a stand-up comic. That being said, our next team is Climate Watt Innovations from Rice University. Welcome.
Hi all, so we are Climate Watt Innovations. Today we're going to present Zpryme, which is software as a service for enhancing resilience of the grid. My name is Aman Sharma and this is Harrison Lewis, and we are graduate students at Rice University. So let's talk about the balance, why balance is really important to keep the lights on in our homes. Because energy cannot be stored in large systems currently, supply has roughly equal demand at each point of time. But we can have imbalances because of weather, plant shutdowns, transmission failures. In that case, our grid gets upset and it can lead to light off in our homes. The question is, what are utility companies doing for that today? They're investing billions of dollars, roughly 70 billion each year, recurring investments in 2050, because most of the grid that we built was in the 60s and 70s. You can ask, why can't we replace it all today? Well, the cost to replace grid is in trillions of dollars, and given the interest rate environment today, it's very expensive. So what are present decisions made? How do they pick up what to work on? Most of it's based on expert judgment and a transient snapshot of the power simulation. But I think we can do better with our technology. So Monstera is a proprietary tech from Idaho National Lab. It's a framework for predicting, for doing probabilistic risk analysis for the grids. What we do is we use probabilistic risk assessment framework for the power flow simulations. We leverage changing data such as weather, changing grid conditions, and we predict what will fail, under what conditions will it fail, what are the chances of failure, and what are the potential costs of that failure. I have five. So the way we make decisions is in 5 steps. So first step is we collect the data from our customers. We feed that data into the step 2 for the models for the power simulations and risk assessments. In step 3 gives us what will go wrong. Then we couple the step 3 data with the probabilistic risk assessment framework, and we try to come up with likelihood of failure, what elements will go wrong, and what's the dollar impact. And step 5 leads us to informed decision making through the power of our 3 models, which are Powerworld, Sapphire, and the Powder models.
All right, so what does doing better actually look like? So let's look at a case study. So let's say a utility company loses a large transformer. Not only are these very expensive pieces of equipment, but they have a long lead time, currently estimated between 20 and 36 months. And again, these systems are networks with nodes of many different pieces of equipment. So if you lose one, the demand on other nodes increases and the risk of further failure increases. So how does our software help? So now let's say that company loses the same transformer. Now they were able to pre-order that transformer based on risk metrics provided out of Mastery. So they have shorter lead times. Furthermore, we have data on how the new configuration reacts with that one piece of equipment being down. So a new prediction of risk metrics, providing us with what else needs to go wrong. So again, we're looking at proactively managing risks to electric grids based on data. So along with the direct cost savings and benefits provided by our software, there's some indirects. So by increasing the reliability index for utility providers, we're able to lower insurance premiums required by insurance companies on grid and operating companies. So they're less risky companies. In addition to that, being less risky means they have lower debt financing costs. As Aman mentioned previously, this is very expensive equipment and a lot of it is financed. So if we could reduce their cost of finance by increasing their reliability, there's some serious saving numbers in that. So specifically, let's take PG&E as a case study. So they have a high risk from wildfires that previously made the company almost go bankrupt. The existing decision is very conservative to shut off operations in large areas. Very non-data driven, very blanket approach. So with Mastery, we're able to make data-driven decisions to shut off power in high-risk areas so the company can maintain operations. And then forward-looking, we're able to look at new loads coming onto the grid, such as additional demand from data centers and various demand coming in from EV charging stations, both in commercial areas and in residential areas. Ultimately, yeah, making the power grid more reliable and cheaper for consumers. So how do we actually make money? So running the software is very expensive. This is a large model. So we're going to provide it as a software as a service in conjunction with consulting for these grid operators in kind of a tiered system. So because our software is expensive to run, we're going to meet the grid operators where they need us at. So if they need many iterations of this model, we're going to charge them more for it. If they're a smaller utility company, we're going to meet them where they stand. We've identified a service obtainable market of 67 million based out of our total addressable market size. And then looking forward at the energy transition, with solar and wind coming on, there's a lot of variability in that, the intermittent nature of that power coming into your system, wind, solar. We're able to model some of that and provide, again, data-driven decisions to help incorporate those new power sources into the existing grid.
So again, we are Mastery.
Happy grids start here.
Thank you so much.
All right, any questions? 2 minutes, 45 seconds. Questions?
Well, maybe we could start with where you are today and what inputs you've put into the system already to start being able to provide insights.
So the question is what is going on today in the terms
Yeah,
of
like
simulation?
where are you at?
So we have the bio steps. So we have all the software built up for that. We just need to partner with the energy utility companies. I'm from understanding the talking with the people who invented the software at Idaho National Lab. They had some traction from bigger energy companies, but still they need a little bit more funding from the government side to make that happen.
So they had some traction with Duke Energy, which is a utility operator, and they were previously sponsored by Department of Energy underneath a funding stream that only funds hard tech. And because the software ended up ultimately being a software driven, they got dropped from that. And so their progress has actually slowed down. So we're trying to revivify that.
I guess just to follow on though, so is there actually like data filling the software today, or is it software sort of in a void with no data yet? So you need to have customers in order to start having the algorithm work.
So there are three softwares, three data-driven softwares, the Powerwall, Zpryme, and the Powder. So energy companies already use a Powerwall model, which is a snapshot in the time. So they already have input for that. What we come and specialize is we have a Zpryme and Powder model. We input probabilistic risk matrix and then couple them with the physics-based inductions to give us better results. That's where our data generation is. And utilities already have the Powerwall model with them.
Yeah, thank you.
Have you done any customer discovery? And if so, what were the key findings of that experience?
We have not specifically, but previously the customer that they had involved was Duke Energy, and that has since no longer progressed.
So one of the things identified in the market is there is not offering like this anywhere in the market. All the solutions right now, even the consulting companies, is just a snapshot in time power model. That's what everyone uses, and depending on how comfortable they are, they use that model with their expert judgment that I think this could go wrong.
This is a little bit of a hypothetical question,
Okay.
but it's about behavior change. So you're going to provide the grid operators with these potential risks, but what evidence do you have that they'll actually change behavior from this model as opposed to sort of waiting until the problem hits?
Yeah, so I don't have anything directly on changing their behavior, but kind of the way I think of it is we're providing data. So they've got a lot of different nodes of equipment that have a chance to fail. So right now they're using some tools that they have at hand and a lot of professional judgment to determine which piece is more valuable in the long term to repair in order to increase grid resilience and reliability. This software will be able to provide a quantitative number on all of those nodes to say, hey, this one is the most important one. This is where you'll get the most value.
Just quickly on that. So just to add, so changing the behavior in sense, I work in probabilistic risk assessment roles for oil and gas companies. It takes time, but as long as the value is involved, which we are providing in terms of money savings and where to invest the money, it's very easy to change the behavior.
Awesome, thank you so
Thank
much.
you. Really appreciate it.
All right, so toward that topic, as they were discussing, my next joke does relate. So how many software engineers do you need to change a light bulb? It's a hardware problem. So let's see, what else can we talk about for a moment while the judges are making some notes? I think if you attended the keynote and thinking about the electricity that's been used all day for us to be here, and the Texas and ERCOT and reliability, I think in all the things that everyone's been presenting, what comes to mind for me is how much more goes on in every one of these subjects that any one of us thinks about every day. Like we take so many things for granted, whether it's the plastics, whether it's the electricity, whether it's all the farming, all these different pieces. And so I've really appreciated everything that everyone's presented, just to remind us that in whatever subject it is that you choose to spend your time, there's a lot more to learn. So excited about all that you've been presenting and the work that you've put in to learn about all of this. So with that, I'll turn things next to Marla Harvey and Ross Fly from Duke University. Yeah, welcome. And Optigen.
Hello, my name is Marla Harvey,
And I'm Ross Fly.
and on behalf of a much larger team back home, we represent Optigen, a state-of-the-art solution for power generation dispatch. Currently, the way that power generation dispatch works, a grid operator, also known as a balancing authority, will consider all the possible solutions for what net electricity demand could be. Then they subtract what is expected from variable renewable energy supply in order to make a prediction on what net power demand will be through a forecast. That forecast is run through a dispatch optimization software through energy management companies in order to schedule generator dispatch. Importantly, dispatchers try to prioritize using the highest amount of low-cost, low-emission generators, but because of differences in generator attributes, they also have to use high-cost, high-emission generators. The problem is there's actually quite a bit of uncertainty in what net demand is going to be. So you can imagine planning around a forecast that is similar to the black line, but you see a real-time net power demand of the larger or smaller net power actual real-time demand, you will have to adjust very quickly. This results in a higher deployment of high-cost, high-emission generators than is optimal. Thankfully, Optigen has a solution. Through its state-of-the-art algorithms, it is able to optimize around the full probabilistic forecast of potential demand scenarios in order to deploy more low-cost, low-emission generators and fewer high-cost, high-emission generators than is currently considered. When modeled across, or when compared to current practice technology, Optigen outperforms current practice consistently. We actually see a 2 to 6% savings when compared with current technology. And when that scales throughout the United States, the societal benefits are significant. We expect to see $3 to $9 billion when deployed across the US. Much of this will be passed along to consumers based on the electricity business model. And we are prioritizing customers with the highest exposure to disadvantaged communities in our early deployment. Emission savings will also be significant, with 35 to over 100 million metric tons of CO2 expected to be saved annually.
So our go-to-market strategy starts with focusing on large, innovative municipal balancing authorities, and particularly those serving justice-supported disadvantaged communities. We'll begin with pilot programs where we demonstrate those 2 to 6% cost savings before moving into a performance-based pricing program where 80% of the savings will go to the utility and 20% will go to us. Now we know that it can be very difficult to break into the utility segment, and therefore, if this approach doesn't work, our alternative approach to entering this market is to partner with incumbent energy management system providers as a plug-in to their existing technology. The way this looks is that in the first several years, we'll need to bring on a couple engineers and a couple of experienced business development leaders to build out that pilot program. We'll then move into our operationalized phase, where we convert some of those initial pilots into paying customers, as well as begin to pilot with vertically integrated utilities, as well as independent system operators. It's during this time period that we expect to hit financial break-even. That'll launch us into our final stage, which is scale. We start to bring on more paying customers. We really ramp up the size of our team a lot. We hit a major milestone that we're targeting, which is over $500 million in fuel cost savings to our end customer. From an economics perspective, we anticipate that our initial customers, this will cost them about $5 million per year, but they'll get cost savings of $20 million per year. They're currently paying on the order of 1 to 10. We'll need $2 million to fund that pilot program, and then we'll need another $2 million to get us through the operationalized program before we're finally profitable in year 4. And this puts us on our long-term growth plan, which is that we don't want to be just a single solutions software provider. We want to build out an entire suite of softwares to allow us to become the go-to provider for grid optimization services. And with that, I'd like to thank the members of our team who couldn't be with us here today and open the floor for any questions.
Thank you. We have 3 minutes for Q&A.
I guess I'd love to hear a little bit more about the how. You talked about how the traditional balance optimization software results in more use of high emission generators, and that yours would somehow allow for the use of more low ones by knowing more about you being able to deal with the variety of what actually happens. But I don't think I get how that translates, how the software actually facilitates, the use of these lower emission generators.
Thank you. So the key difference is a deterministic versus a probabilistic forecast. In the current model, they use probabilities to create a one forecast line and then deal with uncertainty through a buffer. In our model, we would use a optimization method that considers the full range of probabilistic scenarios in order to result in a different combination of generators that more optimally handles a variety of conditions.
So are you running multiple simulations on those scenarios to inform their decision, or you're modeling it differently?
We're modeling it differently.
Okay, and it's not simulated after that.
No, it's a single run, and basically like the crux of the matter comes down to the fact that these lower cost generators, they're often like slower ramp up and ramp down. So when you solve this optimization problem with existing software, you're trying to account for like some capacity buffers. But you're having a harder time accounting for those ramping speeds. Our optimization technology basically allows you to better account for that, and so you can kind of plan out your generation in a way that you can leverage more of those low-cost generators.
And how, if at all, could this accommodate the addition of things like energy storage, batteries, VPPs, other more nimble ways of getting energy on the grid?
It allows you to consider more variation. So we're going to see more variation when we have things like distributed resources and more renewables.
And we mentioned a 2 to 6% cost savings in our current grid system, and particularly Duke Energy's that we've modeled to start. Those cost savings are around 2%. As we increase renewables usage and we see more of that duck curve and more of the challenge with the ramping capabilities and also more uncertainty, that allows that actually pushes us more towards those 6% cost savings. So the benefit grows as we bring on more renewables, and it accounts for storage. In our modeling, we account for growth in storage as well.
And where are you at from a traction point of view? What exists today, and are you in pilot with any particular customers yet?
No, we're not in pilot with any particular customers. The founders of this technology, who are professors at Duke University and Dartmouth, they've worked with Duke Energy and building out the software itself, but we're still at that stage of trying to find that initial pilot customer.
Awesome. Thank you very much.
Thank you.
All right, I'm gonna try one more joke that involves the name of this next team, but it might be a little bit awkward or not. We'll see. Someone's laughing, but they might know what team it is because it might be their team. But after a genome gets his ice cream, how does he eat it? He licks. And the next team is Helix Carbon from MIT.
I can't focus on my judging.
Pretty much time to judge.
Yeah, can we judge the jokes too?
Right, what do you got? One. I was just thinking about someone licking ice cream, but we're looking for some notes and maybe take another 15 seconds of quiet. Silence is awkward. All right, so I'm gonna get your microphone. Okay. And look at all this great way I'm killing time. It's just by dropping things and using it up. But I see some scores almost finished. And all right, are we ready? All right, we're ready. Helix Carbon, MIT.
Thank you.
So I'm Evan Haas. I'm a graduate student at MIT, and at Helix Carbon, we are transforming carbon dioxide into valuable chemicals. So basically, in every emission scenario that we look at, we need not just carbon reduction, but also carbon removal to achieve net zero. And these approaches that we have to doing that today, things like direct air capture and CCS, are these fundamentally added costs for their operators. There's no internalized economic benefit, and so as a result, they've been really challenging to scale. And in parallel, we've built this entire carbon-based economy where for everything from plastics to fuels to paints, the source of that carbon atom is fossil fuels. So if we want to phase out those fossil fuels, we need to find a new source of carbon. And so the sort of logical mental leap then is to say, can we combine these two trends? Can we use the carbon dioxide we are emitting as that carbon feedstock in our economy? But this hasn't happened because it's just too expensive. So if we look at the simplest carbon-based fuel, carbon monoxide, it's also known as syngas, and it's sort of this important chemical feedstock and fuel. It's a $60 billion market. And today it costs around $600 per ton of syngas. And you can use electricity to go directly from CO2 to syngas using electrolysis. But again, it's too expensive and there's been no commercial deployments of this technology. But what we've done at Helix Carbon is by combining dramatic improvements in the energy efficiency of these systems, as well as a lot lower material cost that actually goes into these, is reduce that levelized cost to $350 a ton. So we're actually competing directly with fossil-based syngas. Now, the way that we're able to do this is sort of by solving what is a fundamental challenge in electric catalysis. So in electric catalysis, there are these two form factors, I guess I could call them. The first is dissolved catalyst, where you take your catalyst, that molecule that is helping you convert CO2 to fuel, and you just dissolve it in solution. And this allows that catalyst to interact really nicely with CO2 because it's also dispersed in that solution, but it physically separates it from your energy source, your electrode. And so those electrons have to sort of jump from electrode through solution to catalyst, and that distance comes with an energy penalty. So these systems are quite inefficient. Commercial systems, like a hydrogen electrolyzer, they solve this by plating metallic catalyst directly on the electrode. And that solves that adjacency challenge, but these plated metals, things like platinum and iridium, they're really expensive. And so they're, again, just too expensive to sort of achieve commercial takeoff. What we've done is used DNA to solve those challenges. And we're not using DNA as a biological material anymore. We're actually using it purely as an electronic one because DNA is conductive at the nanoscale. So we take one half of your DNA double helix, we bond it to our electrode, we take the other half and bond it to our catalyst, and because DNA binds to itself, when we flow those together in solution, it tethers catalyst to electrode. It sort of forms this, I call it like a nanoscale wire that allows that catalyst to float around in solution, interact with CO2 really efficiently, while keeping it tethered to the electrode. So there's a really efficient transfer pathway for electrons to get from electrode through the DNA to our catalysts. And it may sound a little bit weird, but the impact is really dramatic. So we have achieved 30% better energy efficiency than any CO2 electrolyzer out there today. We've also shown that when you tether catalysts with this technique, they last orders of magnitude longer. And so this stability allows us to lower our operating costs. And finally, we do all of this while achieving high enough product purity. We don't need secondary purification. And so we are taking this to market by building a drop-in, self-contained carbon to fuel conversion system that circularizes the carbon cycle at industrial plants. We take in the CO2 that they're emitting, convert it to the fuels that they need on site, and then sell that back to them. And this allows us to be sort of capital light. We're focusing on the part of the value chain where we have an advantage, which is the electrolyzer, and we're not trying to build our own plants. We're not trying to compete with petrochemical companies. We actually want to partner with them to lower their carbon emissions. So what do they get out of this? They obviously get that carbon intensity reduction. They get insulation from what has been a pretty volatile natural gas market over the past few years. And they also get the supply and operational security of on-site production. We get to capture that margin between our cost to produce and the current price of syngas. And I want to sort of emphasize these economics don't include a carbon credit or any kind of 45Q or anything like that. So we actually think over time we can improve on these numbers. So like I mentioned, we're starting in syngas as our first product. We're targeting the methanol production facilities in the Southeast US because they produce pretty pure CO2 emissions and they need syngas as a chemical feedstock. There's really no other way for them to decarbonize. And from there, we're going to expand to a broader suite of carbon-based fuels with a particular focus on ethylene using a suite of proprietary copper-based catalysts we've also developed in our lab. And we have the team to make this happen. So I'm a graduate student in mechanical engineering at MIT. I have a background in catalysis and commercializing emerging energy technologies. David's an operational leader. He spent 8 years in the Army leading large-scale combat operations. He was also supposed to give this talk, but had a baby about 24 hours ago, so he couldn't make it, obviously. And of course, Professor Errol First, who is the co-inventor of this technology, and joining our team as a co-founder as well. So with that, I want to thank you and invite you to join us in closing the carbon cycle.
Thank you. 2 minutes for questions.
This is very different than anything I've ever seen. Yeah. Super cool. I'm curious what stage you're at and you know what that means for the development. I see that you are envisioning more of an electrolyzer stack.
Yep.
But what scale are you today?
Yeah, so right now we're about this scale. We just sort of came out of the bench, I guess I would call it. We're in the process of building our next, so that's our next prototype that we're building right now, sort of our 1,000 liter a day. That will be the exact same form factor, exact same cell design as our commercial unit. And so that's going to be the one that we essentially use to test it against the suite of contaminants that you would see in commercial combustion effluent. We're going to run it across a range of different power stabilities, all those kinds of things that make us really understand like what's the lifetime of this thing. And from there, we have a couple of commercial partners we're already talking with that essentially have said, if you can hit those benchmarks, then we will buy it. But that's really sort of our key catalytic fulcrum that we want to hit, is getting that prototype completed. And we think this would be super helpful in helping us get there. Like that's going to be our critical proof point. But as I'm sure you know, electrolyzers are pretty modular. So once we get there, we think that we can sort of just stack it and scale from there.
And the vision is to do point source capture?
Yeah, we don't want to deal with the sort of transportation challenges and all of that around syngas. We want to do on-site circularity. So point source capture. We essentially see ourselves as both a capture and conversion system because we can take in sort of most effluent, including contaminants, directly. So we want to take in point source and convert to fuel on-site.
Awesome. About 25 seconds left if someone's got a quick question. Hearing none. Thank you so much.
Thank you. Appreciate it.
So the filler for this small bit of time is to ask the judges if any of you would like a glass of water.
I'm good.
No, everyone's good?
Yeah.
All right, finally fell.
Thank you.
All right. Our next team is going to be Awanga from Emory University. We'll give the judges a moment, and I'm going to get some water. Still see some notes taking happening. So the next thing I'll say is that while the judges are deliberating, I do encourage you to go attend the Energy Thought Summit sessions that are happening. So if you've looked at their agenda, there's some really nice sessions. You can also go to, I think it's just energythoughtsummit.com and see their agenda for the rest of that activity. So they should have something starting at 3:10. So we should end at 2:55. 3 o'clock, and then there should be a 10-minute break that they have already built in, and you should be able to join a few of their sessions between 3:10 and 4:55, and we'll join in the main session to announce some results. With that, I think I've used up enough time for our judges, and I will introduce again Awanga from Emory University. Welcome. The clicker is a good idea. There you go.
Perfect. Yeah, hello everyone. My name is Benny, co-founder of Awanga, and we're unlocking Africa's energy potential. Before I dive into our mission, I want to show you the roadmap to the company, summarized in foundation, perspective, innovation. Foundation. I grew up like this, without electricity. And it wasn't until I was 8 years old that I realized I didn't have electricity. I was spending the weekend at my grandparents' house, and I accidentally knocked off the only lighting source, a candle. We lost our house, a dog, and I have a scar to remember from that day. Perspective. It wasn't until I moved to Canada and America I realized something. I had access to electricity 24/7. I was able to perform much better in school and even join the U Auto varsity rowing team. Innovation. During my second year of law school, I exited at a place called Pause Between Home. And during training, I lost power for 2 hours, and it took me 3 weeks just to understand what I was doing at my job. Over 81% of people in Congo still face the problem of the lack of electricity, and 14.2% of Native Americans right here in America don't have access to electricity. They're using dangerous, dirty, undependable solutions. Kerosene causes 600,000 deaths, generators highly pollutive, and candles. We know the story behind that. And the off-grid market opportunity is huge. It's $1 billion market and it's ever growing. Now meet 3 of our customers. Souza and Jose, 2 business owners, one in Congo, one in Puerto Rico, and Jessica, a university student in rural Arizona, who all suffer from the lack of electricity. 2 business owners that can't make a profit and a young student that can't study. And meet our solution, the Chisun, an energy storage distribution unit made with second life batteries and plastic bottles for the casing. And the swap station will be released in December. We'll be placing this in universities in rural communities, allowing students to swap their battery packs on the go. And here's what our solution can power up. Finally, customers like Souza and Jose can finally make that much needed profit, serve their customers, and young students like Jessica have the ability to study for the exams. And we make our battery packs with sustainability in mind. One Chisun is made with 15 hard plastic bottles, 42 old laptop batteries, and one Chisun in its lifetime will reduce 0.21 tons of CO2. All our battery packs are connected to the grid, allowing us to track where our battery packs are going, but to also collect important data to create bigger and better solutions for our customers. And here's how our rental model works in developing nations. You rent a battery pack from us, you pick it up at our location, use it for 24 hours, you return it the next day. All this is for $2 a day. We handle the charging at our facilities that have solar panels installed in it. You just come and play and go. And our innovation is also electricity as a service. That's cost effective, $2 a day compared to the $15 that they're currently spending on generators. It's US and Congo made. So for our customers in Puerto Rico and in the States, we actually make it ourselves at Emory University. And for our customers in Congo, everything is being developed in Congo using readily sourced materials. And it's solar powered, gone are the days of those harmful toxic generators. And we make revenue in 2 ways. We rent it out for $2 a day, and we also sell it for $2.50. Unit of production is pretty low at $80 per unit. And since launching in December, our goal was to produce 25 and sell 25, and we achieved that. And our goal for this year is to produce 4,000 units that will net us at least $1 million in revenue. And when it comes to comparison, there's no real comparison. We do have a competitor called Ready that does something very similar to us, but they get most of the battery packs from the States or in China. We control our supply chain by creating everything in-house. And here's how we're going to scale up our solution. So we started off with the small Chisun, but in the next 3 months, we will be moving into healthcare and clinics since a lot of them throw away their own vaccines, and then eventually moving into the e-mobility space and creating charge points in developing nations. And here's the Owanga team. Every single person here has either worked for a startup in the climate tech space or has experience in climate tech, not necessarily with startups. And here's our mentors. Everyone here has either started a company that got acquired or worked for a company that later did get acquired. And our Willie is our governmental connections. As we scale up our solution to more developing nations, her experience working at the World Bank will allow us to open these meetings with various stakeholders. We are raising a small round of 150K, but today's 50K will really make an impact into job creation. We'll be producing 4,000 units. I don't know why I say 3,000. Waste reduction and recycling, repurposing at least 100,000 laptop batteries, 45,000 plastic bottles, and the carbon footprint mitigation will be reduced by 630 tons. I don't know. Well, yeah, thank you.
That's under 3 minutes for Q&A.
Great job. I was wondering about the used lithium-ion batteries. What has to be done before you can use them in your product?
Yeah, for sure. And yeah, when we use our products, we have safety in mind, right? So we do have a third partner in Rwanda and also another partner in Georgia. And they they collect all these second life batteries and test it out for us to make sure that it's safe for our customers. The moment it's safe, they send it back to us, and then that's how we make our battery packs. Yeah.
But nothing has to be done to them?
Nothing at all, just testing to make sure it's safe. Yeah.
I'd love a little bit more detail on sort of both the fixed cost of, preparing this battery up front, and then how you sort of know how long it's going to last, what the useful life is, but then the operational cost. You're charging $2 a day, but you're having to charge them on a grid somewhere, right? And then also the operational cost of swapping them out and all of that. So would love to hear a little bit about the economics.
Yeah, for sure. So in terms of the economics, here's how we're going to scale up our, our rental model, right? Since we are operating in Congo's developing countries, we will be looking at least $500 for office space. And then that will net us at least $9,500 in monthly sales and rentals. And since we are using solar panels to charge our battery packs, we aren't spending a lot of money in that aspect. Yeah.
But have you sort of done any modeling around the useful life of each one of these devices and how long it's going to last? And I assume the lithium-ion batteries come in different states of sort of longevity or whatever. And so how do you plan for that?
Yeah, for sure. So I guess how long it's going to last, we're looking at 5 years. Since we just started launching this in December, we don't really have that much data. But with our manufacturers, as we're developing, we are doing like in-house testing, right? But 5 years is what we're looking at for the first battery pack. And then as it goes lower, we'll probably be giving it a new case. For example, instead of the bigger battery packs, we'll be doing portable batteries for cell phones. So, yeah.
Mike, I think I saw you grabbing a microphone for a second. You have about 30 seconds left.
Question was answered, but I guess, have you explored looking into a program that either Exim Bank or Development Finance Corporation to try to get loans and things like that to expand your businesses?
We have looked at that, but it hasn't been in regards to us getting loans. It's been like we sell our product to them and they just finance it to customers, because that in itself is a different business, and we're just a battery manufacturing company. So, yeah.
Awesome. Thank you so much.
Sweet. Thank you.
All right. So last, but certainly not least, of a very long day of 28 presentations, I'm excited to be introducing this team in just a moment. I'm looking at my notes here, and someone on the team is in the School of Nuclear Engineering. And so as I think about that, it makes me think about atoms. But remember, you can never trust them because they make up everything. There we go. They do make that. All right. I have one more about electricians. What is an electrician's favorite city? There's some debate. Some say it's Atlantic City, but I believe it's DC. All right. With that being said, everyone's ready that that's probably the last one you're going to have to hear. And so I will introduce Jonah Lau and William Appel of Appel Industries, Purdue School of Nuclear Engineering. Welcome. I think you're taking on. And this guy. Yep, absolutely. And looks like judges are just about ready for last but certainly not least.
All right. Good afternoon, everybody. We are Appel Industries, and today we're going to talk about taking back the energy ecosystem.
So you might recognize this behind me as a typical electrical grid as seen in any K through 12 textbook. Very simplistic model that Jonah and I would have seen in elementary school. But while we were looking at this model, we were also, the society was using flip phones. Then in middle school, society was using BlackBerries. Now we're at the 15th generation of the iPhone. That is how technology is supposed to evolve. But this electrical grid has looked almost exactly like this since the 70s when it was first implemented.
Yeah, so we're here at the Energy Thought Summit, and we will be talking about the transition to renewable energy sources, right? Yeah, that actually scares us a little bit, because in the next 25 years, the world will see a 40% increase in energy demand due to an unprecedented economic growth. And that, with our aging electrical grid, is going to cause some major problems from two key issues: network instabilities and network inadequacies. That being said, we are nuclear engineers, and we're here to tell you that these two issues are not mutually exclusive.
Now, these instabilities and inadequacies account for $1.4 billion lost in the energy grid every year. And who is bearing the brunt of this this $1.4 billion?
Regulators, system operators, utility providers, and broke college students like William and I. Everyday consumers. Everyone is losing out to an aging electrical grid.
But instead of thinking about it as everyone that's currently losing out, think of it as everyone who has the ability to gain improvement on the electrical grid. So really briefly, a comparison between the current electrical grid and our proposed solution, based on 3 key metrics for any modern day electrical grid. First, power balance. The current grid receives a rating of 2 out of 4 stars for power balance because while voltage is able to be distributed wherever it needs to go, topological losses account for massive deductions in available power. Next, sustainability receives 1 out of 4 stars because the implementation of clean energy sources into our current grid is extremely difficult. Next, inclusivity receives 1 out of 4 stars because voltage distribution to voltage distribution to marginalized communities will require massive investment that these communities simply cannot afford during the energy transition.
Absolutely. So on the brighter side, we're proposing something called the GPVD. And the GPVD will essentially control every single aspect of your energy grid, scoring 4 out of 4 in efficient power balance. The GPVD will also recycle existing energy infrastructure to provide and cater for renewable and sustainable energy sources, scoring 3 out of 4 in foundational sustainability. The GPVD, with its effective distribution of power, will ensure that typically marginalized communities will not be overlooked upon, scoring 3 out of 4 in increasing inclusivity. Now you might be asking, what does the GPVD stand for? Well, essentially it stands for the Gaussian process voltage distribution, and is a coupling of 2 novel technologies. First of which is the kernel-based Gaussian process regression. Now I know these equations might seem complex, but they're used by nuclear engineering researchers at Purdue University to develop an AI model that can accurately predict energy demand for nuclear power generation.
The second technology is the hierarchical voltage distribution system, which was first initially implemented in the University of Colorado, where they organized the voltage consolidation for wind and solar power plants. Our system simply turns that on its head to map out and distribute voltage in the most efficient manner possible.
Now, I want you to imagine a future where we combine these 2 technologies so we can predict energy demands across the continent and map that on your electrical grid, resulting in lower energy bills and your conscience cleaner and clearer from dirty and deadly carbon-based energy.
Now, is this all economically feasible? Yes. With an initial investment of $350,000, we'll be able to prove viability of the system, coordinate with Federal Energy Regulatory Committee, independent system operators, and utilities. Next, a contract of $3 million allow utilities to increase profits, allow consumers to decrease their energy bill by up to 25%, and allow the energy that implements this GPVD system to be viable within 5 years. But we want to take it one step further, because with an additional $40,000 investment, we will be able to implement the Energy Ecosystem 1.0.
So the Energy Ecosystem 1.0 builds on the success of GPVD with the design of an equitable solution with potential for game-changing impact. So leveraging the GPVD success for power distribution, coupled with an in-house developed application, users will then be able to trade on energy differentials across the continent where GPVD is implemented. With regulatory oversight, the profits would then be reinvested into clean energy solutions and communities that are adversely impacted by the energy transition. So to make all this successful, we want to emphasize that if you as the energy consumer gains through the GPVD and the Energy Ecosystem 1.0, we succeed. So venture with us as we secure capital funding.
Partner with us as we work with FERC and utilities to develop a proof of concept.
And then we'll develop pilot communities and districts.
So take back the energy ecosystem with us.
At Lapel Industries. Thank you.
2 minutes exactly for questions.
I love the enthusiasm.
Thank you.
Are such a difficult concept, really, that was wonderful. I'm still, though, unclear on your business model. I don't understand how you are getting revenue.
Getting what?
Revenue.
Revenue.
Yeah, and how your customers are benefiting from it. Can you go through that one more time?
Yeah, of course.
Yeah, sure. So customers like utilities will be able to benefit by losing less power during transportation to an end user, right? So all the topological losses that would typically be expected in an electrical grid that are just accepted as a cost of doing business will be mitigated. So the end user isn't paying for all the losses to transport the energy and to use it. They're just paying for their own usage, and all that surplus capital will be split between the consumer and the utility. And our business model is we planned for 22 weeks to develop white papers and a proof of concept that we can show to FERC, ISOs, and utilities to market our products. Then within 3 years, we plan to have the legislation in place as well as the manufacturing infrastructure.
Yep. So to be clear then, because it's more efficient, utilities don't need to produce as much power, and as a result, they're saving
on O&M costs.
On O&M.
And multitude
And
of
then
others.
you're saying they're passing on those savings to their customers. Got it. Okay.
And to elaborate further, we work with the Indiana Office of Energy Development, and we've got contacts with them, and we've already started talking with them on this business idea. Yeah.
Awesome. Well, thank you so much.
Thank you.
All right, so we've made it through 28 presentations, and I'm going to let you guys go. We actually finished 3 minutes ahead of schedule, so big round of applause to all of you. I'm going to put out a final reminder, or Jackie will put up a final reminder for our feedback form. So it's 2:50. The next session for Energy Thought Summit won't take place until 3:10. Only 12 teams of 28 have completed it so far. If you want to write with an actual pen and paper, see Hannah right there by this giant column, and she'll give you a piece of paper. Yes.
It's the same feedback form that was filled out.
It's similar, but not quite. It's a little bit different and really focused on sort of after participating this whole time, like if you have any words of advice or feedback or more from like the celebrating your success, like what's the biggest thing you learned or the, your takeaway from that activity. So for those of you who made it all the way through to this date, these questions are a little bit more focused on sort of you and sort of what you benefited from and what we could do more of in the future. So last year we heard from this survey, how valuable the in-person activity was. Could you have more teams? How long the presentations should have been. We will often hear they should be longer. They should be shorter. You're a bit of both. You'll never win successfully, but I'll go through all of that. That being said, don't want to take any more time. We will come back just at the main room, so in the really big room on the 3rd floor to announce the winners. I think their session ends at 55 and the overall program is supposed to end at 5:05. So somewhere in those 10 minutes is where Energy Thought Summit will allow us to the stage to announce the winners. So please be present for that. And I hope all of you are present, and I hope many of you get to win. I know many of you will get to win, but I also want to recognize that you all made it here. Like this is the top 15% of the teams that applied, and those are only of the teams that participated in the program to begin with. So thank you for being here. Truly excellent. I wanted to give an opportunity on the spot without warning to the judges to see if they had anything they wanted to say to you as well, since we have them here as a captive audience, just in general, in terms of experience here, advice, recommendations for life, whatever that might be. I'm going to put you on the spot.
I guess I'll just say I'm a VC, so I see pitches all day, every day, and these were really, really polished. Some of them could use, missing pieces and things like that, but the presentation skills in here were amazing. And I feel like given the short amount of time you had to deliver information, you really packed a lot in a way that was still, understandable to us as judges. So I was really impressed. So congratulations. I imagine you guys put a lot of hard work in, probably practiced a lot, and it came through. So great work.
Thank you. Anyone else?
I think all of you know how I feel, but after going through this, I'm so impressed. Really amazing work. These aren't easy technologies to explain, and then putting a business plan on top of that in a short amount of time. I'm very, very proud. Proud father.
Me too, man. Me too.
And I would just underscore everything that was said already, but also say that if you are continuing and you get a chance to work with I-Core or the other programs that support any kind of customer discovery work, I'd definitely lean into that and take advantage of these opportunities because it will help you refine everything that you're doing.
Thanks so much. Mike, any closing thoughts?
I would just add too, very impressed by all of you, very polished with just such a short amount of time you had to present. I judged some other programs for, business school, case competitions, things like that. And I would say a lot of them had 30 minutes to present and they still didn't get through all of the material that you guys did to make it easy for us to understand what you're talking about. So great job.
Thanks. And I will say one other thing that I just really like about all of your participation, that some of you didn't even know what technology you were presenting on as of February 1st when you agreed to do this thing, right? You said, oh, I have to register. And so between February 1st and now, you learned all those details. For others, you've been studying technology for years, but you haven't been doing the business plan perspective. So all of you have grown in that activity. And I think seeing those of you with a business background, with an engineering background, with no energy or business background, being here and presenting, just congratulations to all of you. That's enough speeching from us, and have a good next couple hours. We're going to have a very difficult next couple hours, 90 minutes to somehow decide these things. But good luck with everything, and we'll see you in 95 minutes or something like that.